Hello, dear students. Can you hear me? Yes, no, say something, guys.
Yes.
Yes. Very nice.
So you'll be starting a new chapter today, right?
I could not hear you. Can you repeat?
So you'll be starting a new chapter today, right?
Motion in 1D. Yeah, we will be starting something new. But 1 second. Anyway, I'm setting it up. Just 1 second. Guys, can you see? I'll let you know. Give me 2 minutes. Guys, can you see my screen here? Yes,
Yes.
sir.
Yes, sir.
Okay, cool. Okay. So so any new students are with us, like first time joining in? Oh, okay. Okay. Yes, guys. So quickly recapitulating what we studied in last class. So we started out with units and dimensions, and we talked about fundamental quantities, auxiliary quantities, how to do measurements of error, the different types of errors. Okay, we calculated that. And there is this concept of combination of errors, like when there are multiple quantities involved, how do you find out the error in them is something that we discussed. And then we ended that class. So that means from chapter number one more topic is essentially left, and that is significant figures.
So you covered it last class.
I covered it last class. Wait, am I looking at
It
the
was an
wrong?
introduction to motion in a straight line.
Okay, 1 second. Am I looking at the wrong notes then? Oh yeah, sorry. I was looking at the previous to previous notes. Sorry, guys. So in last class, what we did is we did dimensional analysis. And after we did dimensional analysis, we did a bunch of questions on it. And yeah, then we did significant figures. And then we did a bunch of questions on significant figures. And then, okay. So essentially, chapter number 1 is now done. That's units and dimensions. I gave out an assignment for you guys as well. And date of submission is 4th June. Today is supposed to be the date of submission for your subjective assignments. Okay. So in assignment, the subjective assignment, the first subjective assignment, there are 2 questions which I believe are now deleted from NCERT as well. And that's question number 1 and 2. The question that says oleic acid is now no longer in the CBSE syllabus. CBSE finally understood that is redundant, not required, so they deleted it. So might as well delete it from our system as well. We don't need it. But yeah, it's all extra information is always good to know. So if you understood what those experiments are, the parallax method and the oleic acid experiments, it is a very good thing. Okay, so don't be sad over it. Yeah, I learned something new. So apart from that, we are going on track. So let us start our today's session by essentially, talking about units and chapter number 2, which is motion in 1D. Okay. So what we will be doing over, why is this not going away? Go away. Okay, cool. So in the next couple of lectures, I believe in 3 lectures or so, we'll be covering something called the kinematics. Okay, you'll find this topic under the name of kinematics. Okay, in NCRT, this is split into 2 parts. Okay, that's motion in 1 dimension or motion in a straight line. And the next one is motion in a plane. This is a new chapter to answer your question. This is a completely new chapter, motion in a plane. These are the 2 topics that we'll be covering over these 3 lectures. Okay. Don't worry about syllabus completion. We might occasionally get behind school, but we'll cover them up because this is like the first topic that we are going to do in competitive level. So I want to spend some time. So you might feel like sir is going very slow, uh, and we are going behind school. But you have to understand this chapter has very high priority in the sense that it will form the basics. So after your fundamentals are strong, then we'll give appropriate amount of time and we'll catch up with school. But this might seem a little bit slow to you, so I'm just warning ahead. Okay. So also, whenever I use yellow color, please ask me not to because yellow will not be visible in the notes. Okay. So yeah, kinematics, motion in straight line and motion in a plane. So let's quickly explain what kinematics is. Anyone knows what kinematics stands for? Like what does it mean? Okay, do you want me to call names? Okay. Arnav, can you tell me what does kinematics mean? Ooh, Arnav is
I'm
not
not
there?
sure, sir. I think it's
Okay.
like something to do with motion and study
Yes,
of
true. Yes, cool, cool. What I'm gonna do is quickly take the attendance. Arnav, you're there. Okay. Ishani, are you there?
Yes, sir.
Janvi,
Yes, sir.
Purva,
Yes, sir.
Rishi,
Present, sir.
Ritika,
Yes, sir.
Samruddhi,
Yes, sir.
Somil,
Yes, sir.
and Shrishti.
Yes, sir.
Very nice. Everyone is present. Okay. So let's quickly get rid of this. Yeah. So guys, kinematics is essentially that's what our friend here said is absolutely true. Kinematics is the study of everything regarding motion. But one thing we are going to steer clear in these chapters is the cause of the motion. Like why exactly is like I'll say ki, okay, this body has 5 meter per second square or 10 meter per second square acceleration, but I'll never bother about where did this acceleration come from. So kinematics is the study of all the motion parameters except for one singular question, which is why is this body moving? That is taken up after this chapter in a chapter called Newton's laws of motion. Okay, so kinematics is the study of motion and the parameters that revolves around the motion, and you'll find something. Find some of the topics you remember from 9th and 10th standards, like the equations of motion: s equals to ut plus half at square, v equals to u plus at, and v square minus u square equal to 2as. This you might have already done in 8th and 9th and 10th, probably 9th standard you have done that. Okay, so definitely all of those things will be something that you have already done. We'll just see a lot of derivations using calculus and stuff like that. And new things involve like graphical analysis. How do you make graphs between displacement and time, velocity and time, etc., etc.? So those are the things that you can expect in this particular module. Okay, so that is what we are going to do in this couple of 3 weeks. That's the plan. Okay. So this is kinematics. Okay. So before we start the kinematics as a whole, let's talk about all the parameters that we are going to discuss in this chapter, because without knowing all the parameters, you'll not be able to understand everything that I'm talking about. Okay. So let's introduce all the parameters of motion that we are going to discuss in this class. Okay. Right. So the first parameter that I want to talk about is location, or we also call it coordinates. Yes. So I'm gonna pick someone up. Ishani, can you tell me what do you understand from these two words? What is location or coordinates?
So the position of the object that's in motion.
Yeah, cool. How do you generally do it? How do you find out like the position of a body?
So not sure, but based on coordinates.
Yes, cool. So whenever you want to define some location of a body or the coordinates of a body in terms of in a very scientific or technical way, we always start out by defining an origin. Yes. So like, for example, on this particular screen, where is this point located? So I'll define an origin like this. Okay, let's call this point 0, 0, and then we'll define one direction as x-axis, the other direction as y-axis. So now we start measuring the location of this point. We'll say probably this distance right here is, let's say, 3 meters, and this position right here is, let's say, 5 meters. Okay, so how will you define the location or the coordinates of this point? 5, 3. Okay, so this is what location is. This is the first basic understanding. This is how we define the location of a body in physics. Okay, in physics, this is how we do it. This is the location, and it's a set of numbers that gives us the location of the body based on an origin and an axis system that we choose. Okay, so we have to be very careful to let the person know what is the origin and what is the directions that we have chosen as x and y axis. Now, if the body changes its location, if the body changes its coordinates, it's gonna do so in a path. Okay, let's say it came from 5, 3. This is its initial position, and the final position, let's say, is I don't know, 7, 9, and it did so in along this path. This path will have a length. Do we know what we call this path length?
Distance.
Distance. So what is the technical definition for distance?
The total path covered.
Okay, so it's the total length of the path when the body changes its position or location or coordinates. Okay, so that is distance. Distance ka unit is meters. Obviously, the standard unit is meters. Okay, and that is everything that we need to know about this. Now, the third scalar quantity, all of these are scalar quantities, by the way. Scalar quantity, third scalar quantity is speed. What is speed, guys?
The rate of time at which the distance is covered.
Yes, the rate of change of distance. Very important, guys. It's a scalar quantity. Unit is meter per second. Meter per second. Okay. Now, these are the three scalar quantities. And now again, I want to talk about the word rate. Sometimes we use, when there is no subscript attached to it. Now, when I say subscript, I mean like there are like, do you remember I talked about gradient a few classes ago? Gradient or slope. Slope of a line is essentially how much rise happens over the horizontal distance. Let's say this height is 2 meters and this is like 100 meters. So how will you explain this? You're gonna say ki I'm gonna rise 2 meters in height if I travel 100 meters in the horizontal direction. Okay, so would it be a good way to say ki the rate of increase of height is 2 by 100 with respect to distance, with respect to horizontal distance? Will it be a correct statement? Yes, it would. you can use the word rate to define any kind of change with respect to something. Okay, now in here, the rate at which the horizontal or the vertical height is increasing is 2 by 100 with respect to horizontal distance. So it's like the word rate is how much one quantity is changing with respect to another quantity. Now, if nothing is mentioned at the end, with respect to what, we generally assume it is with respect to time. So it is okay to say rate of change of distance is speed, but actually I should write like this: rate of change of distance with respect to time. With respect to time. Does this make sense? Yes, no, say something, guys.
Yes, sir.
Okay, so this is what speed is, the rate of change of distance with respect to time. If we know, essentially, if something is moving in a very straight line, okay, very straight line, we know its initial position to be 2 meters and final location to be 5 meters from the origin, of course, from the origin. Like this is the origin, the body's initial location was 2 meters, final location was 5 meters. How would you find out the distance traveled? It was a straight line.
Final position minus position. It's 5 minus 2.
5 minus 2, that's final location, final coordinates minus initial coordinates. Initial coordinates divided by, oh no, there is no divided by, that's just final coordinates minus coordinates. Okay, so that's 5 meters minus 2 meters gives me 3 meters worth of distance traveled. Now, if I ask you, this happened in, like, say 10 seconds, or let me be very cheeky about this, 1.5 seconds. Let's say this happened in t is equal to 1.5 seconds. How would you find out speed? Well, you will say total distance, that's distance by time, right? Speed is equal to distance by time. I hope everybody knows this from 9th standard, distance by time. So 3 meters divided by 1.5 gives me 2 meters per second. Right there. Okay. So this is the basic way to do this. All of these three quantities are scalar quantities. Understand one thing: speed can never be negative. I want you to explain that statement. Take your time. Think on this. Is this statement true? Speed can never be negative.
Yes, sir, it's true.
Yes. Should I pick names? Yes, Janvi. Tell me.
Yes, it's true.
It is true. Why? Why do you think it is true? Just because I
the
said it, it's not true. You
uh,
cannot
because the distance traveled can never be negative.
That is true. That is true. See, distance can never be negative because even if it comes back, the distance always adds up. This is the basic stuff I think everybody knows. Okay. So as you go, that's displacement. Like if the next parameter that we are going to discuss eventually is displacement, that has the ability to become zero, increase, and then eventually decrease, and then it can go also to negative. But distance is a scalar quantity. If you walk in any direction, the distance that you cover is always gonna add up. Right, guys? So that is why distance can never be negative. Time can never be negative. Okay. Now there is a small technicality there. Okay. So let's quickly talk about the time parameter. I said time can never be negative. That is actually technically not correct. Anybody knows why am I saying that? Okay, cool. So what I mean by that, if I say t is equals to -4 seconds, this actually makes sense in a way. For example, let's say you started an experiment at t equal to 0 seconds. T is equal to -4 seconds means 4 seconds before the start of the experiment, what was the state of the body? Okay. What I should be saying is that delta t should not be negative. Now, what is delta t? That means final time minus initial time should not be negative. What it means is that time flows in a single direction and your final time can never be lesser than initial time. Okay, so time can be negative because we're talking about time stamps here. T is equal to 0 second is when the body started moving, but t is equal to minus 4 seconds means 4 seconds before the start of the experiment, you're telling him maybe the body was moving somewhere, okay, or not moving. But you can say t equal to minus 4 second because it designates a time location or a time stamp that is 4 seconds before the experiment. So that is allowed, okay, but you can never do delta t is negative or t final minus t initial is negative. That is not allowed. Okay, so please note this down. Okay, that the change in time cannot be negative. Okay, change in time cannot be negative. So that's the fourth parameter that we discussed. Time ka unit, everyone knows standard unit for time is seconds. Seconds, ladies and gentlemen. Okay, I'm going to the next page. If you miss anything, don't need to worry. You know I have shared all my notes. Okay, the fifth parameter that I want to talk about is displacement, guys. Displacement. Now, what is displacement, guys? It's the change in position vector. Change in position vector. Change in position. Now you'll be like, sir, what on earth is position vector now? You did not tell us what is position vector. Well, I'm gonna tell you now. Okay. So remember how I said coordinates are scalar. There is also a vector version of it, and you should have guessed it because everything has a vector counterpart. Distance has displacement. Speed has velocity. So even the location or the coordinates also have a vector counterpart, and that is known as the position vector. The position vector. Okay. Now there is a very specific way of representing position vectors. It's the same as position, but the representation is completely different, as in it will have a direction also associated with it. Okay. So let's take the same point. Let's say this is that 2,5 coordinates that we were talking about. So how do you represent the position vector? Well, this is how you do it. This arrow that joins origin 0, 0 to 2, 5 is defined as the position vector, and the symbol for that is r vector. And you know how we represent this? R vector will represent as 2x cap, this we call is a cap, plus 5y cap. This is a completely new sort of representation. People who have attended the bridge course will be aware of this. Who have not, please listen to me carefully. What this means is that you have to travel 2 meters along the x-axis, okay, along the x-axis, and 5 meters along the y-axis to reach that particular position vector, okay, or reach that particular location. There is an alternate way of representing x direction and y direction. Can someone tell me? Quickly tell me.
I cap and J cap.
Noise. I cap and j cap. If you ever see in your textbooks, the r vector is represented as 2i cap plus 5j cap. Don't be afraid. I cap just means in the direction of x, j cap just means in the direction of y. This is the definition of position vector. This gives us again the location of a body, but in the vector format where you are associating not just numbers 2, 5. You're telling you have to travel 2 along x and 5 along y. So let's say this is the initial position. So I hope everybody understood position vector, right? It's a vector. It's a vector that represents the location. That represents the location of a body. And the units are obviously meters. Units are obviously meters. Okay. Now, let's say in the same graph, let's say the initial position of a body is, let's say 2, 5. And let's say it went to some different position RF, that's 3, 7. So first of all, let's write down these position vector, the initial vector. Okay. And I'm not designating anything x and y. I don't like people who do not designate their axis. So please designate your axis, x and y. So our initial is 2x cap plus 5y cap, whereas final position is 3x cap plus 7y cap. Nice. Guys, tell me, how do I find out displacement? I have initial position and I have final position. Use your intuition. Tell me, how do I find out?
Final minus initial position.
Very nice. The final position minus initial position. Now, if you remember from bridge course, how do you subtract these two quantities like 2x cap plus 5y cap? If I have to subtract, oh no, I am doing the wrong thing. First, I have to write the final, right? So 3x cap plus 7y cap. I have to subtract 2x cap plus 5y cap. Okay, so I just plugged in the values, final vector minus initial position vector.
It would be x cap plus 2y cap. Just not
Okay.
subtract the numbers and write the vectors inside it.
Yes. So if you remember this vector sort of thing that I discussed in bridge course, we subtract these quantities by, you know, understanding that x will be subtracted from x and y will be subtracted from y. Your answer will come in x cap and y cap because it's also a vector quantity. Okay, so 3 minus 2 is 1 x cap, right? And 7 minus 5 is 2y cap. Okay, so we just subtract x quantity from x quantity, y quantity from y quantity, and that is how you get displacement. Okay, this is the displacement vector quantity. If they ever ask you, what is the magnitude of this displacement? Now, again, we are not going too much into vectors because vectors will be starting in the second chapter. Maybe next lecture I want to talk about, after the third lecture, maybe in the fourth lecture, I want to talk about more about vector quantities again. But do you know what magnitude of a vector is, everyone?
Yes, sir.
Okay. So basic knowledge, a vector quantity is something that has both magnitude as well as direction. Right? It has both magnitude as well as direction. Well, here the x cap and y cap are already indicating the direction. What is the magnitude? How do you find out the magnitude of displacement? Well, understand what it means. I'm saying here there is a body that is going 1 meters along the x-axis and 2 meters along the y-axis. So what will be the displacement, guys? What will be the displacement? You tell me what will be the displacement. What will be the displacement from this to this?
So root 5.
Under root of
5.
1 square plus 2 square. Okay, so that is how you find out the magnitude of displacement. And do you see those two sticks that I have made in front of S? That means that represents the modulus. That represents the modulus of displacement. That represents the magnitude of displacement. Okay, so that is going to be under root of 5. Okay, so now we have the magnitude of displacements. It's under root of 5 meters. We also have the vector representation of the displacement, that is 1x cap plus 2y cap. Little bit of introduction into what the motion parameters are. This is our 5th parameter, and we talked about displacement. If you have any doubt whatsoever regarding this, feel free to ask at this point. I'm waiting for you guys. No? Okay. Then let's move forward. No doubts. Next parameter that we are going to discuss is, 6. The next parameter that we are going to discuss is going to be velocity. Velocity. What is velocity, guys? Okay, I want someone to answer. Wait, let me check. Purva, would you like to go ahead? What is velocity?
Displacement by time.
Yes, it is the rate of change of. Is the rate of change of displacement. Okay, is the rate of change of displacement. Very nice. Now, again, I have not mentioned with respect to what. That means with respect to what, guys?
So time.
Yes. If they have not mentioned anything, it is with respect to time. Rate of change of displacement with respect to time is velocity. And the unit, guys, the unit for this is again same, meter per second. Okay, cool. I don't think we need to explain a lot about velocity because the chapter is about velocity. So eventually everything will be explained. But one thing I want to quickly talk about is there are two types of velocities, guys. There are two types of velocities. The first kind of velocity is known as average velocity. And that is the formula that everyone knows. That's total displacement. You just do total displacement by total time. And there is this other kind of velocity, and that is known as instantaneous velocity. Okay, I need someone to tell me if they know what is instantaneous velocity. Rishi, would you like to tell us what is instantaneous velocity?
So instantaneous velocity is the velocity of a body at a particular instant of time, and it is given by ds by dt.
Awesome. Really good, dude. Really good. Very nice. See, if I had to explain this in a very easy manner, then something that if I'm traveling from here to school, let's say, I know, let's say the total distance that I'm covering is 1 kilometers. And I did so in let's say uh, 1/10th of an hour. Okay. You know what? The distance from my school, my home to my school is, let's say, 10 kilometers, and I covered it in 1 hour. Guys, what is my average velocity here? What is my average velocity? Well, 10 kilometers by 1 hour gives me 10 kilometer per hour. But does this mean that during my entire journey of 10 kilometers, I was traveling at 10 kilometer per hour? No. Somewhere when I had the traffic, I was traveling at 0 kilometer. Maybe I stopped somewhere, it was 0 kilometer per hour. Maybe there was a free road, I was traveling at 60 kilometer per hour. But the average is essentially taking into account the total displacement and total time. It is not a very good indicator. Like, for example, I want to, essentially give the performance of a child. What did I do if I take the average of the entire class and I talk about, okay, the average of the class is this. That's not a very effective tool to check performance. Okay, we have to know about the instantaneous. That's what is the performance of the student, not the entire class, the particular student. So instantaneous velocity is like that. Okay, at that particular instant, what is the velocity at that instant? Okay, now that is given by one particular tool in math, and that is known as the differentiation tool or differential operator. The differential operator. Okay, I'll write differentiation. It will be, calculus will be used to find out instantaneous velocity. Right now, the learning outcome is that I need you to understand what is instantaneous velocity. What is instantaneous velocity, not how to find it, because I'll teach you how to find it eventually. Okay, but right now I just need you to know what exactly is instantaneous velocity, and that is the velocity at a particular instant in time. Okay, let's get one more page, and let's talk a little bit more about this instantaneous velocity. Okay, so one thing I wanted to point out here is that, let's say we had this table, like there's directly this data, 1 kilometer, 10 kilometer he traveled in 1 hour. Okay, but this some other guy wanted a little bit more accuracy, so he said, okay, 6 kilometers was traveled, out of the 10 kilometers, 6 kilometers was traveled in probably, okay, so first 5 kilometers were traveled in half an hour, and the next 5 kilometers is now traveled in half an hour. Okay, now what does this do? Well, the speed will still come out to be 10 kilometer per hour, but what kind of quantity? And we have done error analysis, so I want you to I want you guys to tell me what happens if I break it into two intervals, like 5 kilometers was covered in half an hour and other 5 kilometers was covered in half an hour. The accuracy of the measurement increased, yes, or I should say precision of the measurement increased. Yes, no, what? Say something, guys.
Yes, sir.
Okay. So if I break this further, like if I break this time into further groups, like I'll say, okay, maybe 0.25 hours, he had traveled 3 kilometers. The next 0.25 hours, he traveled, let's say, 4 kilometers. Next 0.25, he covered 2 kilometers, and the next 0.25 hours, he covered 1 kilometer. Okay, now this gives us a better picture of how the body was traveling. So at this, for the first 1/4 of an hour, that's first 15 minutes, he was traveling at what, uh, 12 kilometers per hour. Yes or no, guys? 3 divided by 0.25 is what? 12 kilometer per hour. Next is 4 4 is 16 kilometer per hour. Next, in here, he was traveling 8 kilometer per hour. And in the next 1 kilometer, he was doing 4 kilometers per hour speed. Do you understand what is happening here? I reduced the time interval further. So instead of doing like 10 kilometers in 1 hour, I'm saying every 0.2525, like 1/4 of an hour, 15 minutes, 15 minutes, 15 minutes data I am giving. Now I have more insight into the, the travel of the particular vehicle. I know for the first 1/4 of an hour, he was traveling at 12, then 16, 8, and 4. The average of all of this is how much? This is actually 10 kilometer per hour, but it gives us a better picture of how the body was traveling. If I do this even further, like if I do it for 0.1 hour, like the first 10th of an hour, what, 0.1 hour, 0.1 hour, I will even get more accurate values. Yes or no, guys? Do you understand the concept, the flow of concept here? Every time I reduce the time interval, delta t, this thing becomes more and more accurate. It becomes more and more closer to the instantaneous velocity. Remember, if I take delta t to be very big, like 1 hour, it is giving me average values. But if I decrease delta t, it is tending more and more towards instantaneous values. Okay. So the idea is like this, like you will see in your NCERT textbook, they have defined instantaneous velocity as S delta S by delta t with limit t tends to 0. I need you to understand what this is. Okay. Now this is a particular mathematical operator called limits. This is taught in maths. Okay, this is taught in maths. How to perform this is, again, not, we are going to not discuss that. I just need you to understand what it means. It means that you are trying to write the average for velocity formula, but you want this time interval to become very, 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 very small. And the word that they use is this: infinitesimally small. It just means it is becoming like 0.000000001. It's a very small number. When you start approaching 0 with your delta t, this whole value starts reaching what? It starts reaching instantaneous values, instantaneous velocity. And in maths, when your delta t tends to 0, that exactly calls for a mathematical operator called the differentiation. Again, I just need you to know the names right now. I'll teach you how to do each and every type of operation. I just need you to know the names. Okay, don't get worried, sir. I don't know differentiation. I don't know limits. What do I do? Well, don't do anything. Just know the names. There's something called limits. What does it mean? It means when your values tend to 0 or any other value. Okay. Limits is essentially like, for example, 1, 2, 3, or I should say like 1, 2, 4, 8. What is this, guys? This is a series that's like 2 raised to power x, 2 raised to power x wala series. Now, if I keep on increasing the x value, this number is going to tend to infinity, right? So whenever we're dealing with infinities and zeros, that is where limits come in. That's where limits come in. Okay, this is that particular mathematical tool that can help us deal with infinite series and stuff like that. Also, when you have things like this, when you want your values to tend to 0, that is where limit chapter comes in handy. And it takes a lot of time to teach limits. So I'm not going to attempt to teach you limits right now. Wherever it's essential, I'll slowly give you the required information. Okay, but limits will be taken up by your math teacher, but whatever is required for physics, I'll teach you on the way there. Okay, don't get worried about, sir, I don't know limits or differentiation. I'll teach you both. How much ever is required for physics, I'm going to teach you. Okay, so this is how instantaneous velocity is defined. It's the rate of change of displacement when the time interval that we are taking approaches zero. I need you to write down this statement. Okay, it is the velocity of a body at a particular instant in time. Okay, in other words, it is the velocity of a body when delta t tends to zero, or I should say when time interval becomes infinitesimally small, or I should say delta t tends to zero. Okay, and then write down the formula like this. Ki velocity instantaneous is actually equals to limit t tends to delta t tends to zero, and then you write delta s by delta t, which is again equal to ds by dt. Now you can write with a different color. I'm going to write. This is what? This is taking limits. This is known as what? Differentiation. And I'll teach you both, but you gotta have patience.
So it should be delta S by delta T.
My bad, guys. It should be delta S by delta T. Okay. Now, I hope you're done with this. I don't want to explain the last parameter too much. Can you guess what it is? And what number is this? I think it's 7. It is the 7th parameter. Yes, guys, tell me, what is the 7th parameter of motion? Starts with A.
Acceleration.
Yes, very nice. Acceleration. The unit for acceleration is meter per second square. Understand, there is no scalar counterpart to acceleration, guys. There is no scalar counterpart. There is no rate of change of speed. It's just rate of change of velocity. Rate of change of velocity is what? Acceleration. Rate of change of velocity is acceleration. Okay. Now, few extra stuff I want to talk about is the rate of change of velocity is acceleration. Sometimes the magnitude of velocity, because velocity is made of two things. You know, velocity is made of magnitude and direction, right? So sometimes you'll get occasions where direction is not changing, but the magnitude keeps on changing. That's like the car accelerating in a straight line. So if you press the gas pedal of your car, the car starts picking up speed. That is acceleration, because the magnitude of velocity is changing. But sometimes there will come times jahan the magnitude of the velocity remains same, but somehow the direction is changing. Like when the car is taking a turn, okay, at a constant speed. Like for example, if the magnitude of the velocity is just 3 meters second, 3 meter per second, 3 meter per second, but the direction is changing, then also we get acceleration. Please understand this, okay? Because it's not the rate of change of speed that is acceleration, it's the rate of change of velocity that we have defined as acceleration. So should you ever get a situation where the magnitude of velocity is not changing, but the direction of the velocity is changing, we can still have acceleration. Can someone give an example for that kind of an acceleration? Anybody knows? I'll be very happy if you know this.
So centripetal acceleration.
Very nice. I'm very happy. What is your name, dude?
Rishi.
Very nice. Very nice. Centripetal acceleration is that kind of an acceleration. Okay, so if you have a circular motion in which a body is traveling in just a straight, why is this not becoming fancy circles? Yes, now it shall become. Yes, if you have a body which is going in circular motion like this. Sorry guys, I have to use orange color. No yellow colors allowed, please don't let me use yellow colors. If a body is moving in a circular motion with a constant speed, let's say 3 meters per second, the body will do so, but as it reaches here, you will see that the velocity of the body now changed. It is 3 meters per second, but it is pointing different direction. So it's a different velocity. So that means there has to be an acceleration that is causing a change in the velocity, and that acceleration actually acts towards the center. And you know, every body which is moving in a circular motion has a acceleration towards the center, and that is known as centripetal acceleration. Okay, just a little bit of side information. I don't think I'll write it down, but this is just a little bit of extra information for you guys. Acceleration is defined as the rate of change of velocity. You can get two situations where either the magnitude is changing, either the direction is changing, or both are changing. So acceleration is required whenever there is a requirement for changing the velocity. Okay, so I hope you understood all the parameters. If you did, let us do some questions. But if you have any doubts, I'm going to give you 2 minutes to just digest everything, look through your notes. If you have any doubts regarding any part of this, please feel free to ask. Ooh. Okay, I'm assuming people don't have doubt. So let us start doing some questions, guys. Let us start doing some questions. The first question that we want to do here is that, let's say, and we will do some easy peasy questions in the beginning. Okay, so don't get worried. J means it's not going to ask you questions like this, but still we'll do them because we need to build the concept here. Okay, so let's say there is a circular track, and the radius of this circular track is r. The radius of this circular track is r. Okay, and the man who is running on this track. Now I don't know how to make a man. I'm gonna try. Oh, that's a fancy man. Fancy man. Walking. Very nice. This is a top view, by the way. This is top view. Like, people are thinking, why is sir making a bug and calling it man? It's a top view. That's why we see the head. Okay. In the top view, I see that the man is running around this circle. And let's say I give you the time that it takes to complete one revolution is 40 seconds. One revolution time is 40 seconds. So the question is like this: at the end of t equals to 1 minute and 2 minutes and 20 seconds, tell me what is the displacement of the man, and also tell me how much is the distance that the guy traveled. Go ahead, tell me. I hope everybody understood the question. Let me repeat the question one more time. A runner is running in a circular track of radius r. To complete one circle, he needs 40 seconds. At the end of 2 minutes and 20 seconds, how much is the displacement and how much is the distance? Yes, Shrishti is correct. Distance is 7 pi r meters and 3.5 revolutions is also correct, but I didn't ask you how many revolutions. How much is the displacement and how much is the distance? Distance is 7 pi r is absolutely correct. Displacement is 2r. That is correct. Very nice. Okay. What about other people? Shrishti, Arnav, and Rishi are participating. Who else? Janvi, Purva, what do you think? Ritika, Samruddhi. It's an easy question. Come on. Give me something. I am more happy with wrong answers than no answers. If you're getting right answers, it's okay. I'm good. I mean, like good. But if you're giving wrong answers, that means you're trying. It's good. It's also good. Yeah. But not giving an answer is bad. Yes. Displacement is 0. Okay. You feel like displacement is 0. Shishti is saying displacement is pi r. Okay. Let's see. I will discuss. I'm happy that you are trying. What about Somil? Somil thinks what? Somil thinks 2r. Okay. Okay. Cool, cool, cool. Okay. So let me quickly talk about this. If you know this thing has 40 seconds, like for example, it takes 40 seconds to come from one location to the same location. Acha, tell me one thing. As the man goes around the circle and reaches the same position, guys, how much will be the displacement at the end of 40 seconds? At the end of 40 seconds, how much will be the displacement? It
Zero.
will be 0. Very nice. It will be 0. Why? Because displacement is final position vector minus initial position vector. If the guy reaches the same position, then there is no final minus initial. It will be 0. Right? Final will be same as initial. So when you do final minus initial, it becomes 0. So that is why at the end of 40 seconds, the displacement will be 0. At the end of another 40 seconds, it will be again 0. So that means at the end of 80 seconds also, the displacement is going to be 0. What about 120 seconds? 120 seconds, guys. Again, at the end of 120 seconds, the displacement will be 0. Okay. The 2 minutes and 20 seconds that I gave is actually 140 seconds. So I know by the end of 120 seconds, the displacement is still 0. The remaining 20 seconds, I think all of you might have already realized that this person is going to reach exactly the opposite point on the circle. So if he starts from here, the boy is going to reach the exactly opposite side. Now, how have you defined displacement? It's the final position, the direct distance between final position and initial position. Okay. So this is the final position. This is the initial position. What is the distance between them? Direct distance. Well, from here till here is r. From here till here is r. So the displacement in this case will be 2r. Guys, this is not displacement. This is, don't think this is along the path, sir. That is not true. Whenever we define displacement, I'll tell you this. Like for example, a body went from A to B along this path. How do you find out displacement in this? You just do this directly. This is the displacement. This is the displacement. Okay. If you ever find out the path length here, this will be what? This will be distance. Okay. Displacement is always final minus initial directly. There is no going along the path. So that is why the displacement in this case is going to be 2r, because the final position and the initial position ke beech mein the gap is that of 2r. So that is the displacement by the end of 2 minutes 20 seconds. Okay, so this is how much? This is 2r. What about distance? Distance is like, we know that this thing did three revolutions. First 40 seconds, then 80 seconds, then 120 seconds. This thing did 3 revolutions. So 3 into 2 pi r. You know the distance around the circle is 2 pi r. So the distance that it covered is 6 pi r in 3 revolutions. What about the last 20 seconds? In last 20 seconds, it covered only half the circle. So half the circle length is how much? Only pi r. So 6 pi r plus pi r is how much, guys? 7 pi r. So the total distance traveled will be 7 pi r. 7 pi r. Okay, so this is the total distance that the body traveled. Okay. Any doubts? No doubts? No doubts? Okay, let's do one more question. Okay, so let's say I have a wheel and let's say it is rolling. Do you know what rolling is, guys? Please tell me you know what rolling is. What do you mean by rolling? What is the difference between rolling and rotating? Yes, I have to pick names, is it? Okay, I'll pick names.
The rolling is when it moves in the road.
Yes, go ahead.
So rotating is in the same place, right? It's just rotating, but rolling, it's moving forward or backward.
Awesome. Very nice. So the difference between rolling and rotating is that rotation happens at a single spot. The axis of rotation is not moving, right? But rolling means apart from, rotating, it's also moving forward. So the wheel at the next instant will come here, right? Yes or no? So let's write some points. Okay, so let's say this point here is A. Let's assume that this point here is B, and let's assume that this point is C. So as it rolls forward, this B thing is going to go up. Okay, this is the next instant. Well, this will be B, this will be C, and this will be A. Yes or no, guys?
Yes, sir.
Are you able to understand? You have to find out how much A displaced, the displacement of point A. Srishti is saying 2 meters, pi r by 2, half pi r, root 2. So Samruddhi, Arnav, and Rishi have answered. Ritika says half pi r. Any other answers? Nice try, guys. Half pi r. Yes, half pi r. Let's see. Okay. Okay, let me help you guys. Okay. The displacement of A to A will be this line right here. Yes or no, guys? This green line is the displacement of A. Let me make it properly. Please tell me if you understand, if you agree with me. This line, the length of this line is going to be the displacement of this point A. Right? Okay. If we drop a perpendicular, guys, right here, can you tell me the length of this blue line, guys? Please tell me the length of this blue line.
So it would be the radius.
Everybody agrees with this? He said it's going to be equal to the radius of the circle. Do you agree with him? Well, yeah.
Yes, sir.
Point A was in line with the center and C. So that means this is now, this height right here is R. Well, can someone tell me the length A to X? Okay. Let's call this
Is
point.
it 2R?
It is not 2R, but let's see. Okay, let's think this point right here is D. Okay. Yes. This point right here will also be D. Yes or no? Say something, guys. If you don't say anything, then I'll be very worried. If this point
Yes.
right here, if we call it D, this point will be D, right? Now, if this thing
Yes,
is
sir.
rolling, if this thing is rolling down, I know the distance A to D. Why? How do I know this? Well, because it rolled down, I know that this length right here, this length A to D will be same along this road A to D. Yes or no? It's not looking like the same because I have made it a little bit far away than it should be. But the wheel and the road were in contact. So the length of the road that was covered between A to D will be same along the wheel as well as along the floor. Yes or no? A to D distance. Yes or no? Please tell me. Tell me if we know A to D. Tell me the length of A to D. This is going to be, someone said in the chat, half pi r. Yes, that is true. Half pi r is true. How do I know this is half pi r? Because for a total circle, it's 2 pi r. And this part right here, the zigzag blue part is actually 1/4 of the circle. So that means this is going to be pi r by 2. If you do not understand, please raise your doubt so that I am able to explain more. I'll explain more. I have no issues. And the questions that we are going to take up are not easy. I'm definitely not giving you easy questions. Okay. Because, and I understand it will feel difficult and you'll be like, sir, I'm not understanding anything. It's not that you're not understanding anything. You haven't have enough practice. Okay. So the idea here is to give, I'll do very difficult questions in front of you. And the idea is that you get demotivated. No, the idea is you get motivated. Okay. See, these are the level of questions that you have to attempt. But don't attempt them directly. First, do easy Chunumunu questions from NCRT textbooks. Build your base is what I'm saying. Build your foundation. Okay, do some questions from NCRT level. Do some questions from assignments that I send you. Do some questions from your modules. Then you are ready to attempt JEE mains and JEE advanced questions. So I'm going to do difficult questions in class because this is the final goal of this course. You should be able to do difficult questions like these. Okay. I can give you questions like, okay, let's say this body goes like this is the distance, this coordinates, find out the displacement. Those will be easy questions, but I don't want you to do those easy questions in this precious time when I'm teaching you. Okay. You should,
So will AX be pi r 2 minus R?
yes, that is true. But here, this distance right here is r. So I need a to x distance, guys. A to x distance that is rightly pointed out by our lady here. It is not pi r by 2. It is actually pi r by 2 minus r. Because the distance from x to d is actually how much? This distance right here is r. Please let me know if this makes sense. Okay, so in this triangle right here, if I make this triangle separately right here, this is the displacement I was looking for. This distance right here we found out as r, and this bottom distance, the bottom distance right here came out to be pi r by 2. Okay, let's move it down, minus r. So can you tell me what is this displacement, guys? What is this displacement of point A? What is this displacement? Under root of r square plus pi r by 2 ka square minus r square. Any part you did not understand, I'll explain one more time. Please ask. Displacement of A is how much? Under root of r square plus pi r by 2 ka whole square minus r square. Please let me know if you have any doubt.
So shouldn't it be pi r by 2 minus r the whole square? Like the whole thing in bracket and
Yeah,
that's
sorry. Yes, that's true. Okay, it should be pi r by 2 minus r ka whole square. A minus b ka whole square is not a square minus b square. Sorry. Sir, can you explain it once again? Yes, I'm going to explain one more time. See, the question was asking what was the displacement of A. Okay, and that green line that joined A and A was the displacement of the point A. Now I need to find out the length of the green line, so I dropped a perpendicular. And I know the length of the perpendicular is r because A and center coincides. X and D are in the same horizontal line. So A to X distance will be same as O to D distance. Okay, the distance from A to X will be same as O to D. Okay, now O to D distance is R, so A to X distance is also R. So in this triangle right here, where we wanted to find out this length, this was a displacement that we were after. I already know the length of one side, that's R. Now the question was, how do I find out the distance from A to X? Well, I know A to D distance. Why? Because along the circle, I know this length. Why? Because the total length inside the circle is how much? 2 pi r. Around the circle, that's the circumference, 2 pi r. And A to D distance is actually 1/4 of the total distance. Why? Because I can break it into 4 parts, 1, 2, 3, 4. So that's why D is A to D distance is 1/4 of 2 pi r. So hence this total length is pi r by 2. A to D distance. But I want A to X distance. So the question was, is there a way to find out X to D distance? Well, X to D distance is capital R because X to D is same as A to O. A to O and X to D are same, right? This is essentially A square. So here this is R, this is also R. So how much will be A to X distance, guys? A to X distance will be pi R by 2 minus R. That's what I have written. And I have represented that in this right triangle. Okay, now the displacement is pretty easy. Under root of R square plus pi R by 2 minus R ka whole square. This is the Pythagoras theorem that I have used. If you have any doubts again, please let me know which particular step you didn't understand. You can ask. The difficulty in the classes are going to progressively increase. Okay. So that is why I will want you guys to essentially go back home and revise stuff. Otherwise, you will get confused in class. You'll not be able to answer. Okay. I'll give you an easy question. That was really difficult. So I'll give you one easy question. Okay. Just to neutralize. You'll have, see, the thing is, J-Mains will not ask all difficult questions. Some of them will be easy questions, some of them will be difficult questions. Your target is to get 190 to 200 marks out of 300. Okay. So easy questions, so you should definitely able to do. Difficult questions also, some of them you should be able to do if you want to get 200 plus. If you are aiming for top ranks, then you should be able to do all types of questions. Okay. Well, the next question is like this. A man walks, wait one second, what was the question? Man goes 10 meters north. Okay. So there is a man, he goes 10 meters north and 20 meters to east. Meters to east. How much is the displacement? And what is the direction? Guys, come on. Come on, guys. You can do these. Now, how do you give, how do you give direction in physics? How do you find out direction in physics? Anybody wants to chip in here? Please let me know. How do you give directions in physics? With angles, right? Angles. So you have to find out the angle also. In which angle is he traveling? This is the standard direction. This is north. This is east. This is south. This is west. Yes, guys, come on. Do this. 10 root 5. Okay, we'll see. There's the displacement. I need more people to answer. Come on. Purva Samruddhi. Somil, you're not answering anything. 10 root 5. Okay. Janvi, Ishani, why are you so silent? Ten root 5 northeast. See, when you see northeast, it's very, very ambiguous. You have to talk about the angle. What angle from north is the man traveling in? Northeast is like very approximate. Direction is northeast. No, it's not northeast. What is northeast? Northeast like perfectly in the center, like this angle here is 45 degrees. This is when you call it northeast. Okay, when you are going in a direction exactly in between north and east. That is not the case here. The man is not going northeast perfectly. The angle is not 45. Yes, Rishi gets it. Nicely done. 45 degrees northeast. No, that is not correct. Let me tell you why. Okay. So first of all, if you make this triangle, if you complete this triangle right here, I want to make the triangle one more time here. This is the triangle. This is 10 meters. This, by the way, is 20 meters. So this is the displacement. This is the displacement. Okay. So while finding out the displacement is pretty easy. It's under root of 10 square plus 20 square. So this is going to be under root of 500. So I think people got this correct. Really happy. 10 root 5 meters is the displacement. If you convert it into decimals, I think it comes around 22.5. That also someone found out. Again, very nice. Okay. Now it's time to find out the angle. Now I was asking what is the angle with the north, because this direction is essentially north. I was asking what was this angle right here? Is it 45 degrees? What do you think? Well, if it was 45 degrees, then tan phi would be what? Tan phi is actually opposite by adjacent. Opposite is 20 meters and adjacent is 1 meter. So tan phi is 2. Tan 45 is 1. So you cannot say this is northeast. It's a different angle. Now, if I plug this in a calculator, phi will be how much? It will be tan inverse of 2. And you can plug this in a calculator. Let me quickly plug this. Sine 20 by 10, not 20 by 1. Sir, 20 by 10, not 20 by 1. Oh, did I write 20 by 1? Oh, yeah, sorry. 20 by 10. This is 20. This is 10. Okay. 20 by 10 is 2. Okay, cool. So can anyone put this in a calculator and let me know for what angle is tan theta 2?
Sir, about 63 degrees.
About 63 degrees. Nice. This is approximately 63 degrees. People, it is, sir, can you explain how to find direction once again? Yes, see, direction can be found by using angles. I wanted to find out this theta right here. Okay, and I use trigonometry for this. I know in this right triangle, tan theta will be the opposite side by the adjacent side. Yes or no, guys? The opposite side is 20 meters and the and the adjacent side is 10 meters. So tan theta came out to be 2. Someone did put this in a calculator and found out that tan inverse 2 is actually 63 degrees. So I'm coming at a direction point. So that means I'll say this person is actually traveling 63 degrees. Okay, why is this happening? 63 degrees from north. The person's actual direction of travel is 63 degrees from north. Does this make sense? Please let me know. Someone asked. Yes, Shrishti. Did you understand how to explain the direction?
Yes.
Okay. So how will I answer this question? I'll say the man goes 22.5 meters at 63 degrees from north. Now 63 degrees from north could be either this way or this way. Yes or no, guys? It could also be 63 degree like this, right? So you'll have to specify is 63 degrees from north towards east. Okay, this is the general convention used to write the direction of a body. 63 degrees from north towards east. Why do I have to mention towards east? Is because 63 degrees could also be like this. And this would be 63 degree towards west. So I hope you understood this. If you have any doubt, feel free to ask, guys. Feel free to ask. Did you understand, Shrishti? Any doubts?
No, sir. Thank you.
Cool. Let's do one question on average velocity, because we did talk about average velocity. Okay. So here is the question. I'll directly paste it this time. Guys, read this question and please let me know if you can answer this. Try this once. I think you can. Okay, this is way too difficult. One second. Now, let me give you an easy one first. Don't do it. Please don't do it. This one first. We'll come back to that question, but first I need you to solve this. This will give you enough experience to attempt the next one. Okay. Do this question first, and then I'll take you to that second question. Stepwise, guys, stepwise. When a baby is born, you should not feed him chicken biryani, although you love it. First, you feed formula food. Okay. Then you probably feed milk. Then you feed chicken biryani, I guess. Okay. I don't know the exact formula, but this is the process. You do not teach very difficult question in the beginning. You will get demotivated. First, do easy questions. First, understand the concept. Then you go into difficult questions. Okay. You know what? For this one, I'll also give you options. Let's say the first option is V1, V2. Second option is V1 plus V2 by 2. Third option is V2 square by V1 square. Fourth option is 2V1 V2 divided by V1 plus V2. Guys, please tell me which one of these options is correct. Option B is correct. Okay. B is correct. B is correct. D is correct. Rishi, what is this? Why you do this, Rishi? Everybody says B, you says D. Okay, guys, let me tell you this. If I ask you, what is the average of 5 and 10 marks? Like there are 3 students, one got 5, the other got 10, the other got 8. 3. What is the average marks? You will do 5 plus 10 plus 3 divided by 3. That's, I don't know how much that is. I think 18 by 3. That's 6 marks per student. Now that is how maths define the average. But did I ever, tell you ki if you have 3-4 velocities, just add all the velocities and divide by the number of terms? That is not how average velocity was defined. Average velocity, if you look through the notes, was defined as total distance by total time. So please understand, option number B is not a correct mundo. It's not correct mundo because you do not just do all the velocities divided by the number of velocities. That's math. This is physics. We had defined average velocity as total distance by total time. Okay, so I have to first
Shouldn't it be
make
total displacement by total time?
yeah, let me explain and then I'll clear it out. Give me 1 second. So let's say the body is going from A to B, and let's say the midpoint here is M. Guys, if I consider this distance as D, can you tell me what is this distance? D. Why? Because M is the midpoint. Person travels along a straight line for half the distance with V1 and the remaining half distance with V2. So I have taken this half point right here. This distance is D, this distance, not distance, sorry, displacement is D, this displacement is D. A to M velocity was V1, M to B velocity was V2. Okay, so I'm going to write the formula here, guys. I'm going to write a formula here. Average velocity is total distance by total time. Okay. So total distance, how much, guys? Total distance is 2 times D. What is total time? Well, that is T1 plus T2. The time it took from A to M and M to B. Now, if I want to ask you how much is T1, guys? So I know the displacement, I know the velocity. Guys, tell me, how do I find out time? Well, displacement by velocity. Time is what? Displacement by velocity. What about time 2? Well, it's again D by V2. I plug this here. 2D divided by D by V1 plus D by V2. Okay. Yes or no, guys? Now, if you take D common from the denominators and there's a D in the numerator, D cancels out and you'll get the answer 2V1 V2 divided by V1 plus V2. So yes, 2 students got it correctly. But again, nice try. It's very nice to try the questions. It is very okay to give wrong answers, because this is a process of learning. If you give it correctly all the time, that means you already know. What's the point of class there? Give wrong answers. It is much better than no answer. Please ask me any doubts regarding this. If you didn't understand any part of this, feel free to ask. Did you understand why B option is incorrect, guys? Please let me know. Did you understand why the B option, sir, isn't velocity displacement by time? Yes, sir. Yes, sorry. I did write displacement, guys. Just not seeing it. It's not distance, it's displacement. Yeah, here. Oh, I think this is where I make a mistake. See, one thing I want you to tell, I want you to know, you know what? I'll teach you through a question. I have a question exactly for this. Please let me know if you have any doubts in this. Otherwise, I'm going ahead. One more question, and then we'll have a break. Okay. We shall have a break. 9 to 10:30. Yeah, that's correct, Mundo. So this is the next question. Ratio of average velocity to average speed is A, greater than equal to 1, B, equal to 1, C, less than equal to 1, D, nota. None of these, none of the above. Guys, come on, try this. C. C. Okay. Tell me why you feel like it's C, Chappy. Let's interact.
Because displacement can be less than distance traveled, but not greater.
But it's not just less than, right? It's less than equal to.
It can be equal to what?
Okay, can I bother you and ask when will it be equal?
When the distance is when the distance between two objects is also equal to the shortest path between them.
Cool, that is correct, Mundo. Sir, is it A? The answer is C actually. So let me explain why it is C. Okay. Imagine a person is traveling in a straight line in the same direction like this. Guys, let's say he went from here to here and this is 2 meters. How much is the displacement? Well, it's 2 meters. How much is the distance? 2 meters. So that means distance and displacement will be same if they're traveling in a straight line in the same direction. But at the moment he turns, let's say he went 3 meters in this direction and 4 meters in this direction. What will be the distance? The distance will be how much, guys? It will be 7. How much will be the displacement though? The displacement will be this, and this is how much? 5 meters. So that means distance will always be greater than or equal to displacement. Distance will always be greater than or equal to displacement. That equal to sign is when it is just traveling in a straight line with no turns and no turning backs. It's like he's walking in the same direction, in a straight line in the same direction. He's not coming back. Okay. So that means distance is greater than equal to displacement. If I divide on both sides by time, I'll get speed is greater than equal to velocity. Okay. So if distance is greater than equal to displacement, divide by time and you get speed is greater than equal to velocity. Now divide both sides by speed because speed is a positive number. 1 less than equal to velocity by speed. And that is what the question was asking. What is the ratio of velocity to average speed is? It is less than equal to 1. So C is the correct option, Mundo. If you didn't understand, feel free to ask. So if we are talking about a body which is traveling in a very straight line and the direction is not changing, then speed and velocity will exactly be same. Distance and displacement will exactly be same. Okay. Did you understand what I said? Please let me know if you understood. If you didn't understand anything, please let me know. Okay. One more question and then the break. Okay. Because after the break, I want to start something new. So that fancy question that I gave you, it's going to take 10 minutes to solve. So try this. Try this, guys. let me help you with the diagram. Okay. So let's say the body starts from A, goes up to, let's say, this point here to B, and there's a midpoint right here, M. Okay. Now, A to M distance, let's say, is D. From M to B distance will also be D. Now they're saying ki A to M, this body has traveled with U, but this D distance was now split into two equal times. This is, let's say, T, and this is also, let's say it's T. But understand one thing right here. If I'm saying time is equally split, it's not necessary that the distance will also split equally. You cannot make a midpoint right here and say is a half, like D by 2 was traveled with V1 and D by 2 was traveled with V2. That is not correct, because the question clearly says first half time. Half the total time taken from M to B is equally split. So it could be somewhere here. Okay, maybe this part took T and this part took T. Depends on the speeds, right? So let's call this T part traveling with V1 and the other T part is traveling with V2. This is the diagram. Please do not understand this point right here where half the time was spent may not be exactly in the middle. It could be in the left, it could be in the right. Depends on the velocity. Okay. Now do this question. V1 plus V2 plus U by D. Well, Arnav, your answer should not have variables that we have considered ourselves. Ooh, it's close, but I feel like some numbers are missing, Rishi. Arnav, the problem with your answer is that it has D. D is something that we considered, right? The question only gave you V1 and V2. So your answer should be in terms of U, V1 and V2.
Okay, thank you, sir.
Yes, try again. Guys, I need you to try this. Should I explain, guys, or is anyone trying? Please let me know if you're trying, then I'll not explain. I'll give you 2 more minutes. Otherwise, I'm planning to explain. Is it, sir, trying? Okay. Sir, is it U equals to 2V plus V2? Sir, I'm still trying. Okay, Purva, try. I'm going to give you 2 more minutes to try this. Okay. Rishit, the answer you have given is coming in the correct format, but I feel like some number is missing. Okay. So
I'm
check
retrying, sir.
yes, check your calculations. Your answer is close. Two V1 U divided by V1 plus 2V1 U. Again, the answer format looks very close, but I'm not getting Correct answer, Janvi. See, your answer should not have D or T. These are numbers or variables that I have decided. We have taken as random. Understand? Oh, sorry. 2v1 plus v2. Shrishti, does u equals, what is u equals to? We have to find out average velocity, guys. U equals to 2v1 plus v2. Well, that may or may not be correct. I don't know. We found a relationship between v1 and v2 and u. But you have to find out average velocity. Nice try though. You'll have to check whether that is true. V equals. This is correct. Rishi got it correct. Nicely done. Now let me explain, guys. Let me explain. No need to worry. With practice, this is again very difficult question. I know it's a very difficult question for people who have just started, solving problems. But again, you have to understand, as you do more and more and more questions like these, you will be able to approach the question better. So if you are unable to get it in the first time correctly, it is perfectly okay. It's like practice. The day you start, learning guitar, it not be like playing fingerstyle songs in day one. You have to do some basic practice. This is what is going on. I need you. This is like full fingerstyle, English song being played right here. Okay. Now that comes with a lot of practice. So guys, listen to this. Okay. Again, I'll start with the basic definition. What is the total displacement? What is the total displacement? Well, it's 2 times d. What is the total time? Well, total time will be, the time for the first one is how much? It is d divided by u. So the total time will be d by u plus the small time t here plus small time t. Anybody has any issues with this definition? Please let me know. I don't know the value of small t yet. I have to plug it in. But total displacement is 2d. Total time will be the time from A to M, which is d by u, easily found out by saying d by u, because d is the displacement, u is the velocity. And then in the second half, M to B, it was t plus t. Okay, now we have to find out the value of small t though. For that, I'm going to consider only from M to B. The M to B distance is d, displacement is d. And I want to write down an equation, and please tell me if that is correct. Okay, v1 into t plus v2 into t is equals to d. Guys, please let me know if this statement is correct or wrong.
Yes, sir.
Is it correct or is it not correct? See, v1 into t will give me this यहाँ से यहाँ तक का distance. Let's call this point as x. So m to x distance will be given by v1t. And when you do v2 into t, it will give you x to d. So if I'm adding v1t plus v2t, that will be equal to d as a whole. Now, if I take t common from in here, I'll get v1 plus v2 equals to d. Okay. So from here, can we not find out the value of time t? Yes, we can. And that is d divided by v1 plus v2. I'm going to plug it here. So d by u plus d by v1 plus v2 plus d by v1 plus v2. So I can actually write this as 2 times of d v1 plus v2. Okay. Now I want to little bit simplify this, because I have to divide it. Displacement needs to be divided by time, and it's like I don't have any LCM here, so I want to take LCM. Let the LCM be u multiplied by v1 plus v2. So in that case, d is going to come common. So I'm going to just keep D as it is. First term will be V1 plus V2, and the second term will be 2 times of U. Everybody understood what I did? I just took LCM and took D common. I took D common from both the terms, kept it outside, and then I took LCM of U and V1. So V1 plus V2 gets multiplied here and U multiplies here. So it's V1 plus V2 plus 2U divided by U V1 plus V2. So if I now apply the formula, average velocity is total displacement by total time. Total displacement is 2D, and you have to divide this by this whole thing right here. Now, if I divide this 2D by that thing, I think D and D cancels out, and you'll have this 2 times of U, V1 plus V2 divided by V1 plus V2 plus 2U. I took 2D, which is the displacement, and I divided it by the total time, which is given by D into this thing. So when you divide this, the denominator of the denominator just comes up. So that's why I have written U V1 plus V2 in the numerator and divided by V1 plus V2 plus 2U. Okay. So this is the correct answer for average velocity. Nicely done. Okay. So where is it? Yeah. Ishani also got very, very close. I think you just missed one variable, right? I think just 2U. Yes, you're saying something, Ishani?
No, sir, I was saying that I didn't get to you.
Yeah, just 1, 2 was missing from your answer. Otherwise, it was absolutely correct. Okay. So, any doubts here? Any part you did not understand? Any particular step you did not understand? So then let's meet at 11:05 p.m. Oh, sorry, not p.m. That would be too long of a gap. Guys, let's meet at 11:05 a.m. and let us continue by we will talk about graphical analysis. This subtopic is over. Okay. We'll talk about graphical analysis and we'll talk about how to do graph related problems. So see you at 11:05 to 11:10. Guys, are we back? Yes, no, say something. Are we back, guys? We, yes. Okay. Guys, do you know what this website is? Have you seen this before? Please let me know if you know what this is. Yes, sir. Okay. Yes, sir. What does it do, guys? Please tell me, what does it do?
That
It is
generates
used.
graphs on giving an input of an equation or a function.
Yes, it helps us make graphs. Okay. Well, I'm going to start with a particular statement that says that any curve on a 2D plane can be written in terms of y as a function of x. So that is the statement I'm going to explain. So if I write y equals to mx plus c, guys, what does it represent? What does it represent? It represents a straight line. Okay, so that means if there is a straight line on the 2D plane, you can represent that with y equals to mx plus c. Okay, now what does m control? M is the slope of this line. So if you change the value of m, let me pull this a little bit bigger. Okay, if you change the value of m, it is going to change the slope of the line. What does c control, guys? C is the value of the intercept. It controls where the line intersects the y-axis. So you can see as I move the value of C, the line is intersecting y-axis at different locations. Okay, so you can see as I make the value of C equals to 0, let's make it 0 manually. 0. Let's go. Sorry, 0. The line is intersecting the origin. If I make it 10, then let's check out where does it intersect the y-axis. Well, this point here is 0, 10, 0, 10. Okay, if I make it minus 10, let's see where it intersects. Well, it is going to intersect at minus 10, 0, 0, minus 10, sorry, 0, minus 10. So that means this value of C essentially determines where is this equation, where is this straight line intersecting the y-axis. So again, back to the original statement. This is a little bit of extra properties I'm teaching you, but the original statement is this: every kind of curve or any kind of figure that you have in 2D plane can be written as y as a function of x. Here y is written as mx plus c. What if I write y is equals to x square? What does it represent, guys? What does y equal to x square represent? Well, it represents, what is this, guys? What is this?
Parabola.
This is a parabola. Okay, you can write anything. What about y equals to sine x? What does it represent? It represents like a wavy little thing. Okay, if I remove this too, do you see what this y equals to sine x represents? It's like a wave like thing that it represents. Okay, what does x square, so where is plus sign? Okay, plus y square is equals to 16 represent. Guys, what does it? It represents a circle. You can see the red one represents a circle. Okay, y equals to mx plus c represents a straight line. It represents a straight line. So you can understand from this, my original statement was what? Any kind of graph or any kind of graph will have an associated mathematical equation where you can express y as a function of x, y as a function of x. And that is what we are going to do in today's lecture in graphical analysis. This is where I want to start. Okay. Every curve, like this is a random curve that I drew here. It's a random curve. Do you see the curve on the screen, guys? Do you see the curve on the screen? Any
Yes, sir.
kind of curve can be represented as y as a function of x, y as a function of x. Now, there are two calculus operators, differentiation and integration, that has different applications in graph. Again, have patience. I'll teach you differentiation and integration, but I need you to know what differentiation and integration does to a graph. Okay. I need you to understand what it does. And in the next lecture, I'll help you do differentiation, but not right now. Okay. I need you to just understand what the use of differentiation and integration is. Have patience, guys. I'll teach you every bit of it, but slowly. Okay. Now, what I need you to write down is that if I do differentiation of a curve, okay. Now the curve could be anything. Y could be mx plus c, y could be x square, y could be sine x, y could be cos x, y could be anything. If you do differentiation on y, what does it give me? It gives me the slope of the tangent at a location. I will write this down for you guys. I'm gonna copy this. 1 second. Okay. And let us take it to our handy dandy blackboard. Share my blackboard. Okay. So what does this differentiation do? Well, when you do dy by dx, where y is any curve, it gives us slope of tangent at that location. And then again, I haven't taught you how to do differentiation. People who have attended the bridge course might know, but people who joined us recently will not know how to do differentiation. I'll teach you again in next class, but wait for it. I'm just teaching you what it does. If you do perform the differentiation, what outcome do you get? You get the slope of tangent at that location. Similarly, what does integration do? If you integrate y with respect to x, then it will give you area under the curve. Area under the curve. Guys, do you know slope can be found in one more way? There is a function in trigonometry that helps us find the slope. Can you tell me which one?
The tangent or tan.
Tan theta. Tan theta. So if I tell you guys, if let's say there is a line, if there is a line and it makes 60 degrees with the positive x-axis, can you tell me what is the slope of this line?
That would
The
be root
slope,
3.
it will be tan 60 degrees, so root 3. Acha, there is a line, let's say this is x-axis, this is the x-axis. There's a line which is perfectly horizontal. It's perfectly horizontal. It's making angle 0. What will be the slope of this line? Slope of horizontal line. Guys, tell me what is the slope of this horizontal line? I need everyone to answer this. It will be how much?
0.
0. Very nice. Okay. Let me ask you a few more questions, guys. Let me ask you a few more questions. If there is, let's say this is x-axis, positive x-axis, and the line somehow goes like below this, okay, like this, it crosses over like that. How much will be the slope? Let's say this angle right here is 630 degrees. How much will be the slope? Well, understand that every time you take angle in the clockwise fashion, you have to designate a minus sign, because the convention for angles is anti-clockwise from the x direction is usually taken positive. So the angle that I gave you is actually in the clockwise direction. So it is actually tan of minus 30 degrees. It's not plus 30 degrees because this is not plus 30 degrees. I'll show you what 30 degrees look like. I'll show you. See, this is the horizontal x direction. and this line right here, this will be plus 30 degrees. Okay, so the slope for this line is actually minus 10 minus 30 degrees, which is minus 1 by root 3. Please let me know if that made sense. Okay, what will be the slope of this line? Well, the slope is given by tan theta. So tan of plus 30 degrees this time. The slope of this line is 1 by root 3. Please let me know if you have any doubts in this. Take tan 150. Well, I'll try to avoid obtuse angles because unless you are comfortable with trigonometry, which you will be very soon, I want to deal only with, acute angles. Okay, so either the line will be like this or the line will be like this. So I'll always take either this, the smaller angle like this, or I'll take below the x-axis. Both of them is fine. But if you know trigonometry a little bit, you know ki if I do tan 150 degree also, then also I'll get minus 1 by root 3. But if you don't know, it is perfectly okay. You'll be trigonometry will be covered in your math. Okay, but the slope of this line is negative because it is falling below the positive x direction. It's not above the positive x direction. Okay, so I hope you understood the difference between plus 30 degrees and minus 30 degrees slope lines. Okay, so there are two ways of finding out slope. One is tan theta and the other way is doing differentiation, which I'll teach you in subsequent classes. Area under a curve can be found out by doing the integration or just using basic formulas by like length or breadth or half into base into height. That is how you find out triangle ka area. Rectangle ka area is length into breadth. Trapezium ka area is half into height into sum of two parallel sides. Those kind of formulas, please revise. Okay. So there are only two things that are important in graph. One is the slope, the other is the area. And I think you should know how to find out both. Okay, because that is what will be required in the next part of the lecture. Okay, so I want you to understand that every time you are facing a graphical analysis question, there are 6 questions that I need you to you essentially ask yourself. Okay, I need you to write these down. Okay, I'm going to show it on the board here. Okay, so every time you face a graph related question, these are the 5 questions that you need to ask yourself. And then I'll tell you how to solve the question. But first I need you to write down all the 5 points. First question is, what does X and Y represent? Second question, what does slope represent? Is the slope increasing or decreasing? What does area represent? And is the area increasing or decreasing, guys? Please let me know if you have any doubt. I'll teach you how to answer these questions. Write down the questions first. I'll teach you how to do these graph related questions very easily. You'll never make a mistake if you understand the process here. I hope everybody has written this down. Okay. Now let us take a graph and let us ask ourselves all the questions, and I'll tell you how to answer these questions. Okay, guys. So you're ready? Let us first take first graph that comes up. Okay. Second. Okay, guys. Check this out. Guys, tell me the answer to the first question. I don't think I need to answer the first question. Everybody can find out the answer to the first question. Guys, what does X and Y represent?
The displacement in time.
Yes, X represents time, Y represents displacement. It represents displacement. Okay, So this is what kind of graph? This is a displacement versus time graph. This is what? Displacement versus time graph. Guys, understand this that you can face different kinds of graph. Okay, there will be velocity time graphs, there will be uh, acceleration time graphs, there will be acceleration displacement graphs. So you can have anything in the x and y axis, but the most important part is for you to understand what graph that is. Okay, so the second point, what does slope represents? That is something. Okay, before we go into the second question, I need you to ask. I need to ask a very simple question to you guys. Looking at the graph, what do you feel? Is the displacement increasing or decreasing? What is happening to displacement? Is it increasing or decreasing?
So it's increasing.
It's increasing because why do you think it's increasing?
So it
Looking at
makes
the
a
graph,
positive angle with the x-axis.
that's what I'm like. I think you have to understand this has nothing to do with angles or slope. Okay, you see that the graph is going up. That means as time progresses, the displacement value keeps on increasing. So that is by just looking at the graph, because this is a displacement time graph. This is a displacement time graph. Talking about displacement is really, really easy from this graph. All I have to use is simple common sense and see whether the graph is going up or down. And you can say, okay, displacement is increasing. And you don't have to use any fancy calculus for this. This you have done 8, 9, 10 standard. I see the graph going up. Graph going up. That's it. So the first quantity that we are discussing here, displacement, does not need any in-depth analysis. We can simply look at the graph whether it's going up or down. This is where one of the students asked me doubts, because sir, if I watch from here, this graph is going down, then could I say that from this perspective, the displacement is decreasing? What do you think? Do you understand his doubt? He's saying, sir, what if the man is not going up, it is coming down? From his perspective, the displacement is decreasing. What do you think? Come on, guys. Do you want me to pick names? Okay. I'll pick names then. Who should I pick? Shrishti, would you like to talk to me?
So
Yes. Shrishti, please tell me, what do you think? The doubt. If the person is looking from top, the displacement will be decreasing. Is that statement correct?
so no, I mean the displacement will be the same, right? The time will decrease, right?
Displacement will be same. Well, imagine if the displacement is 10 meters here. Here it will be less, right? It will be 1 meters. So when the man is coming down, then the displacement is decreasing, right?
Oh, okay.
Okay, that's his doubt. I'm asking whether this is correct or not. See, I'll explain. No need to worry. See, there's a difference between coordinate plane and graphs. Okay, now what is the difference between coordinate plane and graphs? Most of you, I know most of you think coordinate plane is graph. It's not the same. I told you coordinate plane is something like a 2D space jahan pe you have defined x and y, and this is essentially giving me the location of a body 2,5. That means 2,5 is a location on a space that you have defined. Whereas the graph is between two quantities, displacement and time. If I make a graph like this is defining what relation displacement has with time. Like if you make, do you remember how to make graphs? You make displacement, you make a displacement timetable and you note down, sir, okay, t is equal to 0, displacement is 0. That means this is the first point. At t is equal to 1 second, displacement may be 2 meters. So you mark 1, 2. This is the second point. Then you put the third point, fourth point, fifth point. So this graph right here, the graph right here is actually a relationship between displacement and time. Whereas x and y is like actual location and actual paths. Okay. So if you say, okay, a man goes from 2 to 0,0 to 2,5 along this path, that means this man is actually walking along this line. But if I make a graph, there is no man walking on this graph. Okay, you have to understand this is not a path where the man is walking. Okay, so this is not a slide. This is not a slide on which a bacha can slide off. That is not the case. Do you understand what I'm saying? This is not a real it's not a coordinate plane. This is an actual location. Each coordinate here represents displacement and a time. So if I write 2,5, it is not an actual location. This is not an actual path. It means at t is equals to 2 seconds, the displacement was 5 meters. I hope you understood that. Okay, so there is no looking from this perspective. Do you understand what I'm saying? There's no looking from this perspective. Time just flows in the positive direction. You cannot just go back in time. Moving like this would mean your time is decreasing. That does not happen. Okay. So displacement is increasing as the graph is going up as time increases. This is the complete definition here. I hope it clarifies some of your doubts. Did you understand the difference between graph and a coordinate plane? Did you understand the difference between them? Okay, let's move forward. Now, next thing is, what does the next question, if you remember, is what does slope represent? What does slope represent? Guys, quickly tell me, how do you find out slope? We just discussed a few seconds ago. How do you find out slope?
Tan theta.
Tan theta. So what do I need to make is the theta. Okay. So remember, it gives slope of the tangent. So first I have to make a tangent. Guys, do you know how to make tangents? Like if I give you a circle and I ask you to make a tangent here, how will you make it? You'll make it like this. Oh, sorry. Is it a tangent? No, it's not a tangent. It's a secant. The tangent would look something like, tangent would look something like this. Yes or no, guys? If I ask you to make a tangent here, how will you make the tangent, guys? You'll make it like this. If I may ask you to make a tangent here, how will you make the tangent? You will make it like this. Oops. Oh my God. Too much magic is happening. This is how you make the tangent. Yes, guys, this is how you make tangents. So guys, can you tell me how will I make a tangent at this point right here? Well, I'll draw it like this. I'll draw it like this. I'll draw it like this. Yes, this is how the tangent looks. Okay. Now, how do I find out slope of the tangent? You said tan theta, but theta with what? Where exactly, like what? This theta is measured from what, guys? Please let me know. How do I, from where, what do I measure this theta?
So from the x-axis or the time axis?
Yes, the positive x-axis like this. This is the direction of positive x-axis. So this is the angle I'm talking about. This is the theta we are looking for. Now check this. Let me complete this triangle right here. This is the triangle that we completed. So can you tell me, let's give some names to these lengths. What should we give this length name? F and obviously U. Yes, guys, this length is F, the base is U. So can you tell me what does F represent? What does this length represent in the graph? What does any vertical length represent in this graph?
X-axis.
The displacement.
It represents displacement. Why? Because this length is perpendicular. So this is displacement. This is displacement. What about U? What does U represent?
Time.
The time.
It represents time. So if you tell me, okay, sir, you want to know what slope represents? Well, slope is tan theta. But we know tan theta is in this triangle. What will be tan theta? Tan theta will be F by U, right? Because it's a right triangle, and the definition of tan theta is opposite by adjacent, right? The opposite is displacement, opposite is F, adjacent is U. But you just told me, okay, I should not erase this. I'll keep it. I'll keep the tangents. Go down. F by U. F is displacement and U is time. So tell me a physical quantity that is displacement by time.
So it's velocity.
So what is the conclusion from all of this? What does slope represent, guys?
Velocity.
What does slope represent in a displacement time graph? It represents velocity. Guys, that means if I tell you, okay, I'm erasing all of this, and I'm asking you this, okay? I'm asking you this. If I make a tangent like this at this point, and I made a horizontal line like this, and let's say this angle I measured to be 45 degrees. I measured this angle to be 45 degrees. Guys, tell me what is the speed of this vehicle? This graph is between the displacement and time of a car. And I made the tangent, and that tangent I measured to be 45 degrees. Tell me the velocity of the car. Array? Use
So
this,
it'll be
no?
1 meter per second.
Yes, because we just discussed, guys, the slope is given by tan of theta of the angle, and theta is the angle that the tangent makes with the x-axis. And I just said that theta is 45 degrees. So all you had to do was tan 45. So that means 1 meter per second, guys. 1 meter per second. Yes. Now, if I make a tangent at A, why do I have to make a tangent at A? Because I want to answer the next question. Do you remember what the next question was? Did you understand step number 2? What does slope represent? It represents velocity in this particular graph. There is actually a shortcut to doing this. You don't have to make the triangle every time. If you ever want to know what slope represents, take the y-axis quantity divided by x-axis quantity. That will usually give you what does the slope represent in that graph. Okay, so here, like, what is the y quantity? It's the displacement divided by time. What is displacement by time? It's velocity. Guys, in a velocity time graph, what does slope represent? Use this and tell me. If I make a graph between velocity and time, what will the slope represent? Quickly tell me using this formula.
So it would represent acceleration.
Yes, it would represent acceleration because slope is given by y quantity, that is velocity, divided by time. That's meter per second, which is what? Meter per second squared. This is acceleration. Okay. So like that we will do. Okay. So write down the shortcut here. What does slope represent? You take the y quantity, divide by x quantity. That will tell you what is the physical quantity that the the graph represents. Okay. The next thing, part number 3. What was the next question, guys? Please tell me what is the next question. Please, nobody's participating, dude. What is going on? I don't like calling out names, guys. Please participate voluntarily.
The next question is whether the slope is increasing or decreasing.
Yes, awesome. Is the slope increasing / decreasing? How do I know? See, if I want to know if something is increasing or decreasing, the first thing I need to do is take multiple data points. Otherwise, how will you find out whether it's increasing or decreasing? If I just give you one number, okay, 1 meter per second, is it increasing or decreasing? How will you know? You have to find out, okay, as the time goes along, is the value like what is 1 becoming 2, is 2 becoming 3, then you say okay, it's increasing. So I need 3 tangents. Okay, I need 3 tangents. So I'm going to zoom in and I'm going to make 3 tangents and you tell me what is happening to the angles. Okay, so first step, just understand the algorithm here, because you have to do this on your own. You have to make your own tangents and then you have to do this analysis. At A, the tangent would look something like this, straight lines, but it's just touching the curve. Here it goes slightly upwards like this. Okay, and probably if I make it slightly small, at B, the tangent would go something like this, even steeper. Okay, now if I make horizontal lines, this is the horizontal line. And some people ask me, so should I make it here or at the center or at this top? Well, what do you think? What about this angle and this angle? Aren't they the same? So it doesn't really matter where you make the angle. You can make anywhere you want. Okay, it will give you the same angle with the x-axis. Okay, so let's say this angle, let's call it alpha. Here the angle that's made here, let's call is beta, and the angle that is formed here, let's call this gamma. Guys, what is happening to the angles? Is it increasing or decreasing? What do you think? Is the angle increasing or decreasing?
It's increasing.
It is increasing. Okay, so I'll write a bunch of statements. You tell me whether that is true or not. Okay, so I know theta is increasing, right? I know theta is increasing. So can I say tan theta is increasing? Well, yes, if theta is greater than tan theta is also greater. If tan theta is increasing, can I say slope is increasing? Yes, because tan theta represents slope. Now, if slope is increasing and slope represents velocity, in the earlier step, we just established that slope represents velocity, right? So if slope is increasing, so that means I can say velocity is also increasing, guys. Velocity is also increasing. Now, this is very powerful. This is very powerful. In the exam, you don't have to write all of this. Just write velocity increasing. But this is what you have to think one by one. If theta is increasing, then tan theta is increasing. If tan theta is increasing, then slope is increasing. If slope is increasing, then velocity is increasing, because in this graph, slope was representing velocity. Okay, so I hope you understood. This is very powerful. Why? Because this was originally a displacement time graph. But using our knowledge, we have extracted the information of velocity also from this graph. This is very, very powerful. Okay, this is very, very powerful. Please let me know if you have any doubt in this. Any doubt till here? Okay, let's move forward then. In this same graph, what was the fourth question? The fourth question was, is there what does area signify? Well, in this graph, area does not signify anything, because if you take any random area here, again, there's a shortcut to finding what does area signify. But you tell me, if there was a random rectangle and you wanted to find out the area, and let's say this side here is F and U. What is area? Guys, area is F into U. What does F represent though? F is displacement. So this will be in meters. And U represents time. So this will be meter into second. Is there a physical quantity that represents meter into second? No, right? So that means in this particular graph, area will have significance. What is the shortcut, guys? If you ever want to know what does area signify, just take the X quantity, multiply with Y quantity. Okay, so time into displacement means nothing. It means nothing. Okay, so in the next slide, I'm going to write this down. Okay, so fourth question was, what does, okay, someone is chat. Okay, so sorry, what I was saying, area is given by what? You multiply the x-axis quantity into the y-axis quantity. Here it's displacement into time no significance. But guys, tell me, in a velocity time graph, guys, in a velocity time graph, if you find out the area under the curve, what will it represent?
Displacement.
Yes, it will represent displacement. Why? Because y quantity into x quantity, velocity into time is what? Displacement. It gives you displacement. Okay, it gives you displacement. I hope you understood. Please let me know if you didn't understand this. But this is not in displacement time graph. It is in velocity time graph. Area will represent displacement. Please let me know if there is any issues.
Sir, can you explain this again?
Yes. The fourth question was, what does area in a curve represent? Well, to answer the fourth question, you are going to use the concept to find out the area, any area, whether it's triangle, rectangle, you'll always multiply the x length into the y length. So how do you know what it represents? Just multiply and see. Okay. So take the x quantity, multiply by the y quantity, and it will tell you what does area in that graph represents. Well, in our graph, which was originally displacement versus time, if you multiply displacement and time, mathematically you can multiply anything, but in physics it won't make sense. Like for example, what is displacement into time? The unit would be meter second. No, there is no quantity like that. Or is there? No, right?
No, sir.
However, if you change the graph and you find it between velocity and time, and you multiply velocity into time, it does mean something because that's meter by second into second. So second cancels out, it is meter. So that means velocity into time represents displacement. It represents displacement. So if you ever come across a velocity time graph, the area will have significance. Here I have written no significance, but there it will have significance. It will represent what? It will represent displacement. But we'll talk about that when we discuss velocity time graphs. But I'm just telling you how to find out the answer to the fourth question, which is what does area represent? What does area represent? Okay. Now the fifth question does not arise for this particular graph because if area has no significance, what's the point of talking about whether it's increasing or decreasing? Please let me know if you have any doubt till here. If not, then I'm going to give you one more graph and then one more graph and then one more graph. After that, you'll be very clear on what is going on. If you didn't understand any particular part, I'm going to repeat again through the next question. Okay. So please let me know if you have any conceptual doubts regarding this. No. Okay. Then let me ask you one more question then. Let me give you this. Next question, guys, this you have to do yourself. It's not coming up. Yes, guys, this is your graph. I need you to do the analysis like I did in the previous question. Okay. First, where do you start with? X represents time and Y represents displacement, or I should say position. Both of them are correct. This is a displacement time graph or position time graph. That would be actually more accurate. It is a position time graph. Yes. Guys, tell me, what does slope represent?
Velocity.
Awesome. It represents velocity. Fourth step. Slope is increasing or decreasing?
So it's neither increasing nor decreasing.
Ah, awesome. How do you know? Because I told you, when,
So
if
it's
you
a
want
straight
to check,
line.
if you want to check whether the slope is increasing or decreasing, you have to make tangents at different location. If you make tangent here, if you make tangent here, if you make tangent here, and then you make the horizontal lines like this, and like this, you'll understand that the angle is not changing. The angle is not changing because it's a straight line. If it's a straight line, it will have some angle, but that angle is not going to change. Did you understand what I'm saying? If you make one tangent here, and you make one tangent here, and you make one tangent here, all these angles are going to be there, but it's going to be constant. So I'm going to write like this: slope, should not be using yellow. Slope is constant. And we just did the slope represents velocity, so I can say velocity is constant. Now, can we comment on acceleration? Can we comment anything on acceleration?
So acceleration would be 0.
Awesome. This would be 0. Why is it 0?
So because there's no change in velocity.
Yes, acceleration is defined as change in velocity by time. Change in velocity by time. If the velocity itself is not changing, rate of change of velocity is acceleration. There is no change in velocity, then acceleration is 0. Again, do you see how powerful graphical analysis is? This is a graph between displacement and time. I can comment on displacement by looking at it. Okay, displacement is increasing. But looking at the slope, I can also tell that velocity is constant. Displacement is increasing, but velocity is constant and acceleration is 0. So you are able to talk about all the 3 parameters of this motion by simply looking at the graph of displacement versus time. So that is why this is very, very crucial. Okay. One thing I wanted to ask you. Okay, I agree with you when you say velocity is constant. Velocity is constant. But is it a positive constant or a negative constant? That's something that I want to know. Is it a positive constant or it's a negative constant? Guys, tell me.
So it's positive.
It's a positive constant. How do I know? Because the angle that we can make with the horizontal is actually calculated in the anti-clockwise direction. It is calculated in the anti-clockwise direction. That is why it's in the anti-clockwise direction. That is why I already told you in the beginning. I showed you in 3 different graphs. If your line is perfectly horizontal, the slope would be 0. Okay. If it like a line like this will have 0 slope. A line like this will have positive slope. A line like this will have negative slope. I already told this, guys. I already have told you this, because the angle that this makes with the positive axis will be calculated clockwise. However, the acute angle will be in the clockwise fashion. I've told you this. This goes below the x-axis, then the positive axis, I mean the positive x-axis. It goes below the positive x-axis, then it's a negative slope. This is a 0 slope. Okay, please remember this. Please remember this. Okay. If you have any doubts, feel free to ask. Otherwise, we'll do the next question. Okay, let's do the next question then. Guys, I need everyone to participate in this one. Okay, this is a different graph. No, not very much, but still slightly different. Okay, so let's start from the beginning. What does X and Y represent? Guys, quickly, come on, open up your mics. I need everyone to participate. What does X and Y represent? X represents?
Time.
Time, very nice. What does Y represent?
Displacement.
Displacement, okay, displacement. So this is a displacement versus time graph. Very nice. Is the displacement increasing or decreasing? Can we comment on displacement? Please tell me what is happening to displacement.
It's decreasing.
It's decreasing. How do we know this? We don't need no calculus fancy stuff here. we see that the graph is coming down, that means it's decreasing. Okay, I could use, if I want to be more technical, I can say it is decreasing linearly. Can someone tell me what does linearly mean?
Uniformly.
It just means that it's a straight line. It's a straight line. And if I were to write an equation between displacement and time, this would have maximum power of 1. That's the meaning of the word linear. Quadratic means maximum power is 2. Cubic means maximum power is 3. Linear means maximum power is 1. And when you have linear equation, it always makes a straight line. Okay, so that's like, if you want to be more technical, you can say displacement is decreasing and it's decreasing linearly. What about slope? What can we comment about slope, guys?
So negative slope, right?
Yeah, negative.
It's a negative slope. It's a negative constant slope. Yes or no, guys? It's a straight line, so the slope is going to be constant. Yes or no? So that means I will say slope is negative and I will say it is constant, right? So what can I comment about velocity, guys?
Negative velocity.
Yes, it is again, I can say, because slope represents what? Velocity. Slope represents velocity. So I can comment about velocity. I can say velocity is negative and velocity is constant. Now, some of you might be worried, sir, what does velocity negative mean? I already told you that in physics, minus sign indicates direction. That means there was a certain convention when the experimenter did this experiment. He chose the right hand side to be positive. The body has velocity in the left hand side. That's what you mean. That's what is meant by the word key velocity is negative. It means ki whatever the experimenter has set as the positive direction, velocity is in opposite direction to that. I've already told this that the minus sign in vector quantities represent direction. It's not absolute. Okay, it represents direction. So when I say velocity is negative, I mean it is in the opposite direction to the chosen direction of being positive. Okay. Now, again, can I put any comments on the acceleration, guys? What can I say about acceleration?
So it's 0.
Yes, it's 0. It is 0. Okay, so the analysis of this one is complete. And you can write about area. Area has no significance. Still, it has no significance. Why? Because it's displacement into time graph. It is not going to mean anything, even if you find out the area. Okay, let's do more questions. Let's do some fancy questions. Like, it's not fancy, it's like part of this only, but I want to see whether you are able to crack this. Okay, guys, talk to me about this. This is a time and y-axis is displacement. So this is what? This is a displacement time graph. What is happening to displacement, guys? What is happening to displacement? Is displacement increasing or decreasing?
It's decreasing.
Is it decreasing or increasing, guys? Displacement. Is it decreasing?
So displacement is increasing.
Displacement is increasing. Okay, what is your logic for that?
So because we just see the graph that of displacement going up.
Yes,
and then it
guys,
stabilizes.
please. Yes, if it's a displacement time graph, please do not find out slope calculus, random stuff like that. You have done this from 8, 9, 10 standard. If you are given a displacement time graph and they're asking whether the displacement is increasing or decreasing, all you have to see is that does that graph has a upward trend or downward trend. Here the graph is going up. It's going up. So I don't have to use no slope, nothing. I just see the graph going up. Graph moves up. So displacement is going up. That's it. Don't write like this in the exam. This is what you have to think in your mind. You'll just write is increasing. Displacement is increasing. You like this. Just technically, this you'll have to think. A graph is going up, so displacement is going up. What does slope represent, guys? What does slope represent?
Velocity.
Okay, it's a displacement time graph. It represents velocity. Acha, what is happening to the slope though? For that, I need to find out the angles. To find out the angles, I have to make some positive x-axis, right? So let's make this positive x-axis. This is another positive x-axis. Okay, so let's make it properly. This positive x-axis, this positive x-axis, this positive x-axis. So let's call this alpha, let's call this beta, and let's call this small angle gamma. So what is happening to the angles?
So they're decreasing.
Angles are decreasing. Okay. So again, I'll use the whole, I'll write the whole my thinking process here. If angles are decreasing, this implies that tan theta is also decreasing. Tan theta is decreasing. If tan theta is decreasing, then slope is decreasing because tan theta gives a slope. If slope is decreasing, then guys, velocity is decreasing. Velocity is decreasing. Why? Because in the previous step, I just understood that slope represents velocity. So if I come to the conclusion that slope is decreasing, that means the velocity of this body is decreasing. Does this make sense, guys? Okay. Can you tell me one thing, whether these velocities are positive or negative?
So all are positive.
Okay. So all of these velocities are positive because you can see all the angles that I have made are in the anti-clockwise fashion. None of the lines, so this is perfectly horizontal. This is positive line. So these you see all the lines are positive in nature. All the tangents are positive in nature. So these are positive numbers that are decreasing. So if I had to write down, now I want to comment on the acceleration. You know, there is going to be acceleration because there is changing velocity. But will that velocity acceleration be in the positive direction or negative direction? That is something that I want to know. Okay. And that one way of finding it out is by logic. You see that the velocity is decreasing. So definitely the acceleration has to be in the opposite direction, right? The acceleration has to be in the opposite direction. Now the velocity is in the positive direction. So acceleration has to be negative. Does that make sense? There is an alternate way of thinking about this. Then I find that very easy. Okay. What I will do is I will write some hypothetical numbers to represent the velocity. Well, I know the velocity is decreasing and all of them are positive. So it's like initially it is 5 meters per second, then it is 3 meters per second, then it is 2 meters per second, or let's say 1 meter per second. Okay. So what kind of acceleration will cause this kind of a velocity profile? Again, remember, I don't know the values. I'm just writing hypothetical values to represent the values here. Now, this means there has to be an acceleration of minus 2 meters per second square for this velocity change. I hope that made sense. See, what does 2 meters per second square represent? It means there will be a change of 2 meters per second. Okay. What does 2 meters per second square represent? It means there is going to be a change of 2 meters per second. Okay, that's why you get second square. So that means if a body has to change its velocity from 5 meters per second to 3 meters per second, there should be an acceleration of -2. So from there, you can say the acceleration is negative. But understand, I cannot comment on the value of acceleration. I can only say it's minus because these numbers are hypothetical. These numbers are hypothetical. So don't be like, yeah, sir, acceleration is -2 meters per second. That is wrong. You can only say it's negative, but you should not say whether it's a -2 or -3 or whatever. Retardation. Yes, this process of, velocity being in one direction and acceleration being in the opposite direction is known as retardation. It could also happen like this. If velocity is negative and acceleration is positive, then also retardation will happen. Because understand, if acceleration and velocity are in different direction, the body will slow down. Okay. It just like if you see that there is a retardation, if the magnitude of the velocity is decreasing, there's a retardation, and acceleration has to be in the opposite direction of velocity. Please let me know if you have any doubt regarding this. Otherwise, I'll do next question.
So the velocity is negative, right? Because it's reducing.
No, velocity is positive, but it is reducing. Positive numbers can also reduce, right? 5, 4, 3, 2, 1. These are positive numbers, but they are reducing. It's positive. How do I know it's positive? Because all the angles that they are making are positive angles, like you're calculating anti-clockwise from the positive x-axis. Does that clarify your doubt?
Yes, sir.
Okay, all the angles. The next question I'm going to give you will have negative velocities, and see the difference between the two. Actually, I'll put it here only so that you can see the difference. Okay, this one. See this graph. This graph, check this graph out. Sir, so velocity is positive and decreasing. Yes, velocity is positive and it is decreasing. Positive means a direction. Don't be like, sir, how can positive decrease? Well, positive numbers can decrease 5 meters per second, 4 meters per second, 3 meters per second. This is decreasing velocity, right? But all of them are positive. It means it's in the positive direction. However, this one is going to be special. I know I won't do the first set. I think it's too easy now. You know about displacement, right? What is happening to displacement, guys? Come on, quickly tell me on the mic. Displacement is, Lord, please help me. Why is this children not participating?
Decreasing.
Yes, it is decreasing because the graph is coming down, dude. Graph is coming down, so displacement is decreasing. Very nice. Now, I am not going to write this down. This has become too easy now. I think you can handle this on your own. Displacement is decreasing because the graph comes down. There's no explanation required for this. Slope represents velocity. Now, I have to make tangents to talk about whether the velocities are positive or not. So let's make lines. Horizontal x-axis is everywhere. This is the horizontal x-axis. This is the horizontal x-axis. Okay, if I zoom in, how will you make the angles? I told you, always go for the acute angles. Those are more easy to understand. See, I can make like this, but this will be an obtuse angle and you have to involve trigonometry. The acute angle will be like this. The acute angle will be like this. This will be alpha. This will be beta. This will be gamma. Guys, alpha, beta, and gamma, these are positive angles or negative angles? Tell me that first.
So they're negative angles.
They're negative angles, and I have, oh, sorry. Shoot. Yes. What I was saying is, if you have a line like this, there is zero slope. This is zero slope. If you have a line like this, like I'm talking about the tangents here. This is a positive tangent. The angle will be positive. This angle will be positive. Okay. If you have a line like this, which is the case in this one, your slope will be negative. Make this, your life will be so much easier. If the line is perfectly horizontal, it has zero slope. If it goes above the x-axis, like this, the dotted line, this is positive slope. And if it goes below the x-axis, this is negative slope. So you can see all these lines are actually going below. It's following the third one here. Okay, so that's why velocities are positive or negative in this one, guys. Is the velocity positive or negative?
It's negative.
It is negative. Okay, so I'll start from question number 2 here. Question number 2 is, what does slope represent? Well, slope represents velocity. Next question, is the velocity positive or negative? Is the velocity is positive? Oh, sorry, negative. How do I know? Because all the tangents are below the x-axis. Well, the angles, they are subtending. The acute angles are below the x-axis. Okay, so velocities are negative. And is the value of velocity, see, negative implies the direction. But what is happening to the magnitude of velocity? Is it decreasing or increasing? Magnitude of velocity, like the absolute value. Is the car slowing down, or, you know, velocity is increasing? No, it is not. The angle ka magnitude is decreasing. No. See, this is like 60 degrees, then it is becoming 40 degrees, then it is becoming 0 degrees. So if I had to find out the actual magnitudes, it will be something like minus √3, like minus 1.73 meter per second. Then it is becoming minus 1 meter per second. Then it is becoming 0 meter per second. Guys, the magnitude of the velocity is decreasing, no? It has a negative sign, just implies that it is happening in a certain direction. Don't include the minus sign in understanding whether is the velocity ka magnitude is increasing or not. Minus sign just means a direction. It was supposed to be going west, but it is going east. Okay, that's the significance of the minus sign. but the values are decreasing. No, the velocity was 1.73, then it became 1, then it became 0. You can see the angle ka value is decreasing. It is initially 60, then it is closing in and slowly it's becoming 0. So magnitude of velocity will be decreasing, that's children. Please let me know if you didn't understand this one. I'll explain one more time.
Yes, sir.
Guys,
Good.
you got it? The magnitude of the velocity depends on the angle, like the value of the angle. It is decreasing. It is becoming 60, 45, and then 0. Okay. The fact that the velocity is negative has nothing to do whether the magnitude is increasing or decreasing. The negative sign just implies it is in a different direction. Okay. Magnitude is how steep or how big the angle is and how small the angle is at towards the end. As the time progresses, is the angle ka size increasing or decreasing? That is something that is given by that where we need to talk about the magnitude of the velocity. Okay. So that's slope, velocity, magnitude that we have talked about. Now, the last and the most dangerous question here. What can we comment about acceleration? Take your time. There's no hurry. Make a velocity profile that hypothetically represents this, and then give me whether the acceleration is going to be positive or negative. Please don't give me a magnitude of acceleration, because you know we cannot comment on that, because these numbers will be hypothetical. But at least tell me whether it's a positive acceleration or it's a negative acceleration. I'm going to help you with the hypothetical numbers. This is a big negative number. So it's like minus 8 meter per second initially. Then it became minus 5 meter per second. Then it's becoming minus 3 meter per second. Then it's becoming 0 meter per second. This is the scenario right here. What kind of acceleration will cause this? It will be a positive acceleration. It will be a positive acceleration because the car is slowing down. The car is retarding car. It's a retarding car because the magnitude of the velocity, I told you many times, the magnitude of the velocity is decreasing. So that's a retarding car. So that means acceleration should be in the, so if velocity is in this direction, acceleration should be in the opposite direction. That is the meaning of the word retarding or decelerating. When we talk about retarding or decelerating, velocity and acceleration are in opposite directions. So if velocity is negative, acceleration has to be positive. Velocity negative, so acceleration positive. One way of understanding is by logic like that, or plot some numbers and see. It's a negative velocity and the magnitude is decreasing. Plot some numbers and see how is it possible? Should I add a number to this or should I subtract a number? Imagine if I do minus 2. This is not going to become minus 5, it's become minus 10. So I have to add some number here. Plus 3 I'll have to add. Plus 2 I'll have to add. Plus 3 I'll have to add. Okay, so that means this can only be caused by a positive acceleration. This velocity profile will be caused by a positive acceleration. Please let me know if you understood this. Next question you'll do on your own. Guys, next question you shall do on your own. If you understood, you'll be able to do it correctly. Okay, next question for you guys that you will do on your own. Okay, you shall do it yourself. DIY. Come on, I'm banking on you guys. Believe in you, please. I need everyone to do this. Did someone leave the meeting? What is this? Who left? Ishani, Janvi, Purva, Rishi, Tika, Smriti. Somil left. Well, he was not speaking anyway. The class is running up to 12:30. Last 10 minutes will be doubt clearing. But till then, till 12:20, please stay. Yes, guys, please let me know. So X decrease slope is decreasing negative, velocity is negative. Shrishti is okay. Let me see. Yes, Purva has given an answer. Displacement is slope is velocity, acceleration is positive. Okay, Shrishti and Purva have given the answer. I'm waiting for other people to type in. Type in your answers. Janvi has also answered. Very happy with your progress. Rishi, Ishani, Arnav. Yes. 1x time. What is 1x time? I don't know what 1x time means. Sir, is the velocity same? Theta seems to be same. No, theta is not same. Are you making positive x-axis everywhere? Okay, so I'll help you by making positive x-axis. Nobody is going to help you though in exam, but I'm going to help you anyway. This is positive x-axis. This is positive x-axis. This is positive x-axis. So initially the angle is very small, then it becomes slightly big, then it becomes very big. Sorry, sir, I made mistakes. Sorry, sir, I made mistakes. Thanks. Okay, it's okay to make mistakes. This is the time when you should make mistakes. In the exam, you should not make mistakes. Ah, very nice. I'm very happy, Rishi. Flawlessly done. Acceleration, you can only comment. Ritika, nice try, but you can only comment whether the acceleration is positive or negative. You cannot say it's decreasing. I think you mean negative. Okay. When you say acceleration is decreasing, it would mean you know the magnitude, but we don't, right? And also, rather than saying velocity is increasing, please say magnitude of velocity is increasing. That way you are more correct. This is also correct. Velocity is increasing. But I think you missed one, Ritika, which is like whether velocity is negative or positive. Okay. And yeah, guys, you have to be very careful what you are writing. Okay, be very, because I told you, no, science subject is very objective, very technical. You cannot give like a velocity is negative. Yes, awesome. You have to be very specific and very careful of what you write. Displacement slope is decreasing negative. Yes, slope is decreasing negatively. Ah, yes, you can say that. Some would be it's decreasing. Okay. Okay, I'll let's just check all your answers. Please check your answers. I'll fill it up. X represents time. Yes, one more answer has come in. Velocity is negative. Yes, velocity is negative is absolutely correct. Awesome, guys. Awesome. Awesome. Purva has done it. Yeah. Samruddhi has done it. Ritika. All of you, thank you so much for participating. Arnav is also trying. Samruddhi, Janvi is trying. Shrishti is trying. Arnav is trying. Rishi is obviously good. He did it correctly. Is there anyone left? Please, guys, if you are not participating, it's not gonna help you learn. This is it's literally not going to help. Okay. So people who are not participating, you are just, you know, okay. X represents time. Y represents displacement. What is happening to displacement? It is decreasing. How do I know? From the graph itself. I don't have to use no slopes, anything. What is happening to slope? Well, first thing I know is the slopes are negative. Why? Because you can see all the lines are going below the x-axis and all the angles are they are calculated. Yes, Ishani, nice. So all the slopes are negative and they are increasing in value. They are increasing in value. What does this mean? Okay, it's like 0 degrees. It's like minus 30 degrees. It's like minus 60 degrees. So yes, they are negative, but their values are increasing, right? So similarly for velocity, you can say that the velocity is negative, but their magnitude is increasing. The magnitude of velocity, be very careful what you're writing. Magnitude of velocity is increasing. And I know the source of the doubt. Some people will be like, sir, 0 to minus 30 to minus 60 is actually decreasing, no? Because numbers in the terms of numbers, if you say 0 to minus 30 is actually smaller than 0, and minus 60 is even smaller than minus 30. Okay, so there's a tendency for people to say, sir, this is decreasing. But this is not math, children. You're saying a car is traveling at 30 meters per second, and then it became 60 meters per second. And then it's decreasing. How? What is this? This is not math, dude. You have to use physics. The car is speeding up. The car is speeding up. The minus sign just indicates it's speeding up in the west direction. What does it have to do with math? Should you say it is decreasing? Velocity is decreasing. That's very bad. You should not say velocity is decreasing. You should say the magnitude of velocity is increasing. That would be correct. It is negative means it is actually what can I say? It is speeding up. The car is speeding up in the opposite direction than a chosen direction, but it is speeding up. So you should say magnitude of velocity is increasing. Now, this is a scenario where you are talking about the car accelerating, right? It's speeding up. So it's not retardation, it is acceleration. This is acceleration happening in the car. So acceleration and velocity has to be in the same direction. So velocity is negative. That means acceleration should also be negative. Only then will the velocity increase. Okay. So if I had to write some hypothetical numbers, so it would be like initially the car was 0, then it was minus 1 meter per second, then it became minus 2 meter per second, then it became minus 3 meter per second. So it's like the velocity is negative, but it is increasing. So what kind of acceleration will cause this? Well, you'll have to subtract a number. So from this kind of analysis of the hypothetical numbers, also you get the acceleration is negative. Most of you have done it, and I have explained it. Please let me know if you understood. If you understood any part of you, any part of it you didn't understand, feel free to ask. Understood, sir. Okay. I will give you one more graph. Okay, and then we'll probably disperse for the day. I'm going to send you the list of the entire things. Okay, so no need to worry. I'll just paste it here. Just see that this is actually a list of everything that's possible. Every possible graph. I have just made a small graph for that, and I've written everything around it. So go through these 2 pages. Okay, so this is the page, and the next page is this one. Okay, I have taken all the possibilities. There are 6 different possibilities of different types of graphs that usually can come, and just sit through it and don't just memorize it. It's not, you'll not be able to memorize between this and this graph and remember it for 2 years. You're definitely gonna forget if you try to memorize. What you should do is you should take this graph, do it on your own, and see if these are matching. Like velocity is positive, nature is decreasing, the acceleration is negative. So when I say velocity nature, I mean the velocity magnitude here. This means velocity magnitude. So go through these graphs. There are 6 graphs, 2 on this, 3 on this page, and 3 on this page. Okay. So go through these graphs, and how do you go through them? You do it yourself and see whether the answer is matching or not. Okay, you just do that. And then let me know if you face any difficulty. Okay, and let's do one velocity time graph before we leave. Okay, and here it comes. Once again, one velocity time graph before we go. And then from next class, we can continue from here. Okay, last question for the day. This is a velocity time graph. So we'll start from the beginning. What does X contain, guys? X contain time. Y contains what? Y contains velocity. So third question. Oh, third question should be like, before we start the questioning process, what is happening to velocity? Can we comment on velocity here? Quickly comment on velocity. This is a velocity time graph. What is happening to velocity? Is it increasing or decreasing?
So it's increasing.
Is increasing. I don't need no fancy calculus for this. I just see the graph going up. It's a velocity time graph. So that means velocity is increasing. There's no rocket science here. It's the easiest stuff. Yes, it is increasing. Very nice. Okay. Now, question number 2 is, what does slope represent in this graph?
So it represents acceleration.
Awesome. It represents acceleration. Use that original formula. It means, how do you find out slope? Y quantity by X quantity. Velocity by time is acceleration. Okay. Now tell me whether the slope is increasing or decreasing.
Increasing.
Increasing or decreasing? Be very careful. I know there's a lot of questions you have done. It is constant. It is constant, guys. Slope is the angle that any tangent makes with the positive x-axis. You will see all the angles right here are same. All of them are theta. So slope is constant. On a straight line, the slope will always be constant. And it is constant, whether it's a positive constant or negative constant, you tell me. It's a positive constant. It's a positive constant. Okay. Did you understand, guys? So now slope represents acceleration. So what can I say about acceleration? Acceleration is a positive constant. It is a positive constant. Please tell me if you didn't understand this. Please tell me. See,
So is velocity a negative constant?
velocity to, now see, this is, don't mix the previous question with this one. The previous question had displacement in here and velocity was given by the slope. But this is a velocity time graph and the slope is giving us acceleration. If you want to talk about just velocity, just look at the values. This is a positive value, 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 this is a positive value. So velocity is positive and velocity is increasing. So definitely acceleration will be there. And that acceleration comes from the slope and we see that the slope is constant. So it's a constant acceleration, positive acceleration. Does that clear your doubt? Things have changed in this graph because this is no longer displacement time graph. Here we don't see velocity by slope. Velocity is now directly plotted onto the y-axis. Okay, so if the graph is above x-axis, that means all the velocities are positive and the velocity itself is increasing. Okay, all these points represent velocity, so velocity is increasing. The slope will now give acceleration, and since it's a positive angle, it's a positive constant slope. It's a straight line, so all the slopes will be equal. What about area, guys? What does area signify?
Displacement.
Displacement. Awesome. And how do you find this? X quantity multiply y quantity. Okay, so velocity into time represents displacement. What is happening to area? Is the area increasing or decreasing? Area is increasing. You can see, actually, this is not a correct representation. This is not the displacement. Okay, this is the displacement in this small time. If I want to calculate the displacement up to T1, let's say, you'll have to consider this whole area, the whole area from 0 to T1. Okay. Now, if I take another another time, like let's say this is T2. What is the distance covered in T2? Well, this entire thing is the displacement in T2. So as time goes along, green is greater than white. So that means the area is increasing. So that means displacement is also increasing. So as we move along the time axis, you will see that the area keeps on increasing and increasing. So that means displacement will increase. Please let me know if you have any doubt in this. No doubts, guys? Okay, then. Okay, guys, thank you so much for being here. A great crowd. Okay. Take care. Revise and do the assignment that I'm going to send you. Okay. And I will see you guys next time. And take care, guys. I hope you understood everything. If you have any doubts, you can stay back. I'll be here till 12:30. You can ask doubts. Okay. So thank you so much for being here, guys.
Thank you, sir. Bye,
Thank you,
sir.
sir.
Yes, sir.
Bye,
Thank you,
guys.
sir.